participants' benefit purpose. Okay, I'll just tell you about this particular forum, what we are trying to achieve, what is a meetup group and all about. So this meetup group has been started in the year of 2014 in Chennai, and then this is progressively elaborated for the many IT industry people. They collaboratively work, and then we discussed many meetup sessions over there. So based on that, we'll share the knowledge across the uh, people where they want to really learn this technology, and then they can share their knowledge, and then they can get the knowledge also. So this some of the times we'll conduct in the in person, some of the times we will conduct in the web-based model. So this is a community forum. It's a free webinar. You can join and share your knowledge, and then you can get the knowledge also. Okay, so around 3,133 as of date. There are people are in the member across the Chennai. And then for India, we have the another chapter. Those who belong to Bangalore, Hyderabad, and the different locations, Mumbai and Delhi, those people, they can join on the Big Data India chapter. So this is more specific to Chennai. And then for other regions, so we have the chapter runnings for the specific core topics. Those people, they can join through that meetup group. Okay, so here you can go to the, I'll tell you about this particular meetup, how to use this Big Data Chennai chapter meetup. If you are new to this particular meetup, so what are the options you have available? So here you can check that there is a message board will be there. In this message board, you can see that, yep. Okay, in this message board, you can see that what are the messages we are sending to the people, so that you can go through that message, so that any latest message you have received, you can check it out here. And then if you want to go ahead with the discussion, like if you want to start a new discussion, you can click here. Let's start new discussion. If you have any questions, or if you want to share some of the forum topic. So this forum topic, you can just put your title over here, and then you can describe, you can ask a question kind of way, or you can put a new discussion over there. So based on that, the track discussion, you can just submit that. So other people, it is visible to everybody, to this forum, so that the thread will be go along with that particular way. Okay. So this is for discussion board, discussion board. Under discussion,
the chance to be the danger.
And the discussion, you can go through this start new discussion. I'll mute everyone for record purpose. Okay, so this start new discussion, you can create a new discussion for anything, and if you want to put this into track this message board. So another important thing is under the more file sections, you can go through that. What are the existing files we have? So we can go through the how to install the Hadoop, so you can have the Hadoop installation guide. So if you want to submit any files to the forum, you can send the file to me. Based on that, I'll just upload over here. And then there is other options available. You can see through the some of the entry questions available. So this file session is maintained to the maintaining the all the files. So this Big Data Chennai chapter meetup group, which is belong to Chennai community, where spreading the knowledge across the for the big data field and data science field. Okay, so this particular thing is more than 3,500 associates joining together to gain the knowledge and to share the knowledge. It's an active forum for the Chennai chapter. Okay, so this is all about this meetup group, and then I'm just going through this slides. So before moving to that, any other questions you have in your mind, you can just ask me. I'll just unmute that.
Horrible, very bad, special, magic power, acronym, usual, unusual, remember, forget, surprise.
Okay, we'll get started for today's discussion. So today we are going to discuss about the first 10 minutes about what is big data. So these slides have we already discussed many times, and then you can go through this YouTube channels, but I'll give the overview of big data and what is all about. And then currently this big data is the very most wanted technology, and then most wanted platform where you can able to do a data analytical field. This big data is a purely data analytical field. It is most wanted IT field in the current next to 10 years of time. Okay, so this big data is all about, first of all, we have to understand what is big data. So introduction to the big data, which is the big data, which is the collections of data set, which is large and complex, that become very difficult to process using on-hand database management tool. So it is on-hand database management tool is like our SQL Server or Oracle. The collections of large data set, the large means here, it's terabytes of data blocks, terabytes of records. So these records cannot be processed in the, it's very difficult to process in the normal Oracle or SQL or any other on-hand database management tool. Okay, that's why this big data field is very key to the current market trend, and then it has been widely used in the data analytical field. Big data is not a software. Big data is a field. It's a data analytical field. Under the big data, you have the software called Hadoop. Hadoop is one of the Java-based written software, and similar way there are many other softwares are available. That's called Hadoop ecosystem. So we'll understand more on this big data, who created this big data, when it has been started, and how this big data has come to the picture. This big data word, the big data 3V concept, there is a 3V concept is there. It's a volume, velocity, and variety. So this 3V concept, which is most important concept, this 3V concept has been defined by IBM. Okay, so the big data has been collections of data set which is so large and complex, means it cannot be processed in your normal on-hand database. It is very difficult because you can able to, if a normal like SQL Server or Oracle, it's purely structured data oriented, like rows and columns will be there, tabular columns will be there, there is a data type will be there. If you are considering the internet world, in the internet there is a video file will be there is audio file will be there is a pictures, images, raw text will be there. How can I, for example, the Facebook, if you take the Facebook or Twitter, they're not maintaining that as a table format. That's a raw data, right? So they are not putting that. If you are putting some feedback, or sometimes you are putting the video, sometimes you are putting the images, these are going to storing as the table 1, employee ID equal to 1, employee name equal to ABCD. It's not going to store like that. Video file equal to 1 or 2 3. It won't store in the table format of structured way. It's going to be in an unstructured way or a semi-structured way. So the big data, which is the collections of data set, which is a so large, means it is very large. It is a terabytes of data and petabytes of data, which is very complex to process the data in the on-hand management tool. So that's about the definition of that big data. So in this big data, you can able to process.
English test. English test started.
Is that no issues, right? If I mute everyone, because I'm getting some kind of the child is talking or they're teaching over there. So is it fine, right? If I mute, it's coming from. Okay, I'll just mute for I'll mute for a few minutes, and then I'll, during some question and answer time, I'll just unmute that. Okay, big data, what we are talking about, this big data field, which is comes under the year of the 2003, 2000 and 2003 time. Okay, it is already there. It is already there 20 years back also. That's purely distributed data science model or distributed data algorithm model. That kind of field it is growing. Okay, but the big data, which has been comes into the picture of the year of 2000. So there comes the large data size which need to be get handled. From where this big data is started is, it is started from the Google company. Okay, from the Google, it has been started. So Google is one of the search engine, right? You might be aware this Google search engine, which has been very vastly used search engine by everyone. So when the Google is about launched in the 95 or 96 time, they're processing the search data from the various web server, and then they're putting that URL, then the key tag, everything they are putting over there. Based on that, they are executing that. So they are unable to process very large data in the internet. So they want to manage that effectively. For example, I'm just putting the one of the key text, big data. Okay, if we put that big data, it's coming 0.55 second. Within 0.55 second, it is giving me around 2 crores and 22 lakhs kind of results, which is coming. Okay, so this within 0.5 second, how it's been getting processed? Is it magic is happening? No. So these are already processed data which is available in the Google server. So these data are just reflecting one more time based on the keyword what we are putting. The same thing if you are putting over there in the Yahoo server. Okay, if you are putting the same thing in the Yahoo server, it may give the different result. It may not come the same results. Okay, because they are maintaining their format in the different way of algorithm. So here it is only producing 16 crores or 16 lakhs 90. Okay, one second. It is 1 crore 69 lakhs of records only. But in the Google server, it is giving you around 22 2 crores 22 lakhs of data which is coming. So it's a difference is there, right? So these data, how to manage during that time, 2000 time, they are facing the problem. So it's unstructured data. It's a kind of semi-structured data. It's structured data. It's a combination of all those things. So how to manage that? So they have done a research on that. So they've done a research on the Google file system. It's called Google file system, which will come over there. One second. Google file system. So this Google file system where you can store and retrieve this all the search contents. Based on that, it will work. You can just go through that, understand that more onto the Google file system in the Wikipedia. So this Google file system, which has been used for distributed file system. It is a distributed file system where you can able to store and retrieve. Also, you can go through this big table, how to store and retrieve this particular way of tables handling the data. Okay, so this Google file system, which has been a research publication, which has been it has been performed by Sanjay. Is Mr. Sanjay? He's an Indian origin. So he just performed this in the year of 1999. The distributed system field, he did a research on that, how to handle this particular scenario, how to process the large complex data in a, like Google is facing the search problem, store and retrieve the large data. For storing and retrieving, he found that okay, there is a he found a solution for that. Okay, so that solution he just published as a white paper. Okay, that's called Google file system. So this Google file system, it is just starting point of your big data field or in a Hadoop field. So that is your starting point of your the entire data analytical field. You can say it's on a Hadoop environment side. Okay, so this particular architecture, how it is been storing here, if you consider if you're considering your normal home PC. Okay, in a home PC, what is happening? You have the hard disk for any data which is storing and retrieving in the hard disk. In the normal in your organization where it's getting stored, it is storing on your server. Server also where it is getting stored. Server also is getting stored in this hard disk only, right? So there might be the size may be differ. It may be stored and retrieved in the 1 terabytes of hard disk or 500 GBs of hard disk. And if it is server, you might have 2 terabyte or 5 terabytes of the hard disk, right? So these kind of hard disk where it's getting stored and retrieved zeros and ones of block. Okay, so when it's getting stored and retrieved these zeros and one block, the block size, each block size, hard disk block size, if you put across, these blocks where you can able to see as data the structure of the hard disk, or it's a structure of the wheel where you can able to put zeros and ones. It is a combination of zeros and ones, and there is a block size. Each and everything will be in a block. Okay, this block which is containing the 3 KB 3 kbs of block. It's like a FAT32 system or 64 or NTFS system, any kind of system where you can able to store and retrieve that particular block, where you can able to have the data block, header and tailor, and then this block will have the 3 kbs of block size. Okay, so each block will be containing 3 kbs of block where you can able to store and retrieve the on the particular hard disk. If you want to process large data, if you want to process terabytes of data, it cannot able to then it will be, if it is for 500 MB or 100 MB file, it is fine. So this 3 KB 3 KB model will work. If it is for Google servers going to handle terabytes of data, how to create this 3 kbs of block and then storing and retrieving will be very difficult. So that's why the Google file system, they found that this particular technique or this particular research, Google file system, they created a logical layer on top of your hard disk, on top of your hard disk storage. This is a physical layer, and then on top of physical layer there is a logical layer has been created, the logical layer software. That logical layer will work for you as a logical hard disk. Okay, that logical file system. For example, if I'm opening the this file system, the file manager, so this is a file system for your Windows. So similar way, Google file system, which has been storing and retrieving in the block size of 64 MB block size. The chunk size which has been 64 MB. Normal hard disk which has been storing and retrieving is the 3 KB 3 kbs of block size. Here each and every block size will be 3 KB, but here the logical layer where you can able to put across is the around 64 MBs of block size. It is a, here this is 3 KB, but the logical layer software will help you to combine this 3 KB 3 KB block into one single block as a 64 MB block. Okay, that is the first research. Okay, the Google file system, which is the first research. Based on that, they have found that the another way. Okay, I found the Sanjay specified. I found that how to store and retrieve the large data, but how to process this data. Then again, they face the problem. It is the year of 2000. They published the October 2013. They published as a white paper, and similar way they have not progressed much after that. So they are not implemented, but they want to find another research in the data field. How to we stored only the data as a 64 MBs of block. How to process very fast within a millisecond of time. So when the Google is putting that if any data such is coming within 0.55 second, how to process terabytes of data in a very faster way. For that, they have found that map reduce concept. Okay, so the map reduce is the another Google research paper. The same guy Sanjay is found that okay, we have made that as a Google file system. After the Google file systems, we have created another technology or process methodology, map reduce concept. That is a simplified data processing on the large clusters. Okay, this particular research paper they have put across map reduce model. That's any data which is going to process key comma value pair concept. Okay, I'll detailedly explain when we are discussing about this map reduce. So this paper has been published in the year of 2004. Okay, you can see that the appear in the OSDI in 2004. So that year only this particular big data and everything will be comes into the picture to process structured, semi-structured and unstructured data for the large amount of data. So why this big data is very popular, and then why we need to process this kind of large data, what is the benefit we are going to get? Okay, in last 20 years of the field, we have already automated many software development. Okay, for example, if you take the banking software, you already have the banking software, in mobile banking software, you have all the banking applications are automated. If you take the hospital management software, every hospital maximum they having all the automated software for managing their patient records. If you take any field in this particular world, so you might be have the certain software for processing the data. So each application will produce the data for their particular field. For example, healthcare data will produce the healthcare data, banking data that provide the finance data. Based on this data, how to process the last 20 years of data or last 30 years of data, based on that we can able to do a predictive analytical. So the analytical field is coming into that picture over there. From there, this field has been growing enormously. So that is our need of the particular field. Okay. So for example here, the need of big data analytical, for example, call center people or website, social media, everybody is producing that the data which has been related to their product or related to any kind of business need. This platform will help you for an predictive analytical customer sentiment analysis from the multiple channels. In Facebook, they might be typed about an iPhone. Okay, iPhone, I like this particular version, iPhone 6 or iPhone 7. What are they're putting some feedback, or they're putting the comments, or they're liking the product, or they're disliking the product. Based on that, they're putting a dump text. It's a unstructured data. So this data structure also can be processed, and then to effectively make the decision making or to make the target audience to create a new business opportunity also, you can able to process those data. Okay, so these data can be processed. That's where this big data comes into the picture. So the need of the big data analytical is not only that particular social media or website or creating the data. In current world, 4.6 billions of mobile phones across the world wide, they are producing the data. 2 billions of internet users every day, they are producing the data. An enormous satellite growth, which is every second milliseconds of time, that is producing the weather monitoring system or any kind of satellite feeds of data, which is keep on producing that can be processed. The new media channel like a YouTube, Flickr, any kind of media channels can be emerging every day. People are putting the videos or channels or maybe audio channels. So these data also can be processed for an effective usage. The digital make, and Twitter is producing every day 7 terabytes of data. This data is very, very useful for when you are processing the region specific of any data processing. And strategic growth of the traditional data. This traditional data comes from your normal servers, and Facebook is producing every day 10 terabytes of data in the everyday. So these data can be processed. It is not concerned only with this whatever I specified, but it is example only. Based on that, you can able to understand how much of the volumes of data are produced in the global level. For example, the why we need a big data. The predictive analytical stages, what are the things we can able to do? The physician can able to predict based on the any new diseases is coming. So based on the last 30 years of data, he can able to process, or he can able to do a scientific research over there. And in call center representative, they can able to make sure that there is a social relationship between the customer and then preventing chunks. So the loan officer for the banking application, if you have, they can within a millisecond of time, they can able to process your last 30 years of like a CIBIL score. How the CIBIL scores are working? So the CIBIL scores working is based on your last 30 years of your credit transaction and debit transaction, right? The similar way, the loan officer can able to find the risk tolerance over there, whether you can able to approve the loan or not required to approve the loan. Based on that, they can able to predictive the analysis. For that, they have to process millions of record of your last 30 years of data. So then sales associate, they want to determine that offer and discounts where this region specific people are liking or not liking, where they want to promote the sales. Those things they can process these using the big data analytica. These are some of the field I'm just telling about for an example purpose. Okay, now we have to move to the certain other slides, which is a very important slides. I'll talk about that. Okay, what is the difference between a traditional analytical platform and then big data analytical platform? The traditional analytical platform, which is able to process, for example, the SQL Server or Oracle or DB2 or whatever the data management system you're having, it is can able to process gigabyte to terabyte level of data. But big data platform, now it is we are processing towards on the petabytes to exabyte of data size. The traditional approach, which is the centralized data structure, we have the servers will be in centralized location, but in the big data analytical, we have the distributed data structure model. It has a RDBMS concept, traditional analytical platform, but here this flat schema model. And then batch-oriented data processing model, here it's a real-time, near real-time. It is a historical data only, but it's a near real-time analytical of the data. Analytical based on the historical trend, but here analytical is based on the real-time data. The data is generated through the conventional method. The data can be fed through the data entry model, but here the data is generating using the unconventional model like RFID, sensor, satellite. So many devices are producing the data. That device data can be processed. Some of the case studies you can able to see here, website, e-commerce, and internet. Uh, for example, I'm telling Flipkart is one of the example I'm taking. Flipkart able to launch a product in their website. They want to do a predictive analytical whether this kind of product will be, which kind of product people will be purchase this, or which kind of region I need to promote this product in effectively. So those kind of way they can able to predictive analytical, data analytical things they can able to process. And retail marketing, competitive pricing analysis across the website, you can able to check that which price is lowest price for this particular product, so that you have to process the entire web world to check that competitive price in this same product. Customer segmentations you can do, buyer predictive buyers behavior, market campaigning market. So these are some of the case studies we can able to go through Google. You can understand more things. Healthcare side, you can do a drug discovery of processing the large volumes of data. And then the insurance side, you can do a customer segmentation and service response optimization. Financial services side, you can do a fraud detection analytical and risk modeling side. And then the other media side, you can have the customer satisfaction analysis, dispatch analysis, optimization. Those are so many things can be possible in the each field of domains. Okay, so this is a case study, some of the case study, for example, purpose I told. So this big data landscape will come little later stage so that you can able to understand more. Okay, now we'll move on to the 3V concept. The 3V concept is very important concept in this big data field. The volume, data variety, and data velocity. The 3V word which has been coined by IBM. Okay, the 3V concept is a data variety in terms of it can be text file format, it can be CSV or photo or video. That means this is structured or unstructured or semi-structured. Why big data is very popular? Because it can able to process any kind of data model. It can able to process structured data types, it can able to process unstructured data type, it can able to process semi-structured. If you are having the SQL server, it can able to process only the structured. Semi-structured is very difficult to process, but semi-structured also you can able to process, but it is very difficult to process for a large data. Okay, so but here big data is very easy. If your data size is less than terabyte or less than gigabytes, never ever choose the big data, because this big data is meant for the large volume of data quantity of particular data processing side, data analytical field. If your data size is more than 1 terabytes, then you can choose for the big data or big data field for your data processing. So in the current scenario, the large volumes are more than terabytes only in the internet world. The next one is data volume. This data volume, we can go through one of the slide, then we'll come back to this data volume slide. Here I'll go through the one slide where you can able to understand this particular data volume. So the data volume, so we might be aware of the till the gigabytes level. So in your normal home hard disk, we might have around 500 GBs of hard disk or 1 terabytes of hard disk, but 1024 gigabytes equal to 1 terabyte, 1024 terabyte equal to 1 petabyte. Okay, 1024 petabyte equal to 1 exabyte. 1024 exabyte equal to 1 zettabyte, and 1024 zettabyte equal to 1 exabyte. So these are the structure of the data volumes where we are processing the data. So Facebook is every day they are storing over 1.5 millions of petabytes of photos they are storing. We can able to process those data. It's a publicly available data. The exabyte, currently if you are considering the last 20 years of the world, when the hard disk is found from the hard disk device is found as a research product. From there till the 2010 or 2011, during the time, the data volumes, whatever it is generated in the all the hard disk, it's just 20% of data. So remaining 80% of data which has been produced over in the last 5 to 6 years, 6 years of the time, these data volumes are grown like anything. Next to 10 years of time, if you see that the data volume is going to be in a reach to the etobyte and then other model, zettabytes and etobyte model only. So the data volumes have been very, very large. So we are talking about this big data. It's a very large data we are going to process very easily through the distributed data modeling model. So the data volume we discussed, and the data velocity. The data velocity is how fast we are going to process this data. Okay, we have this structure and semi-structure and unstructured data. The volume size is very large. It's terabytes or petabytes or exabyte or zettabyte of data. And how fast we are going to process these terabytes of data? It is very, very simple. Through the distribution model, they can able to process within a millisecond or few minutes, less than few minutes of time. We can able to process these terabytes of data. That's why this big data is very popular. That's why the Hadoop is very popular in this field. We'll discuss more on that. Any questions on this 3V concept? I'll just unmute this. So you can have any question, just ask me now. If anybody has a question, just please raise it in the chat window so that I'll just answer you while we are discussing. Is it my voice is clear? So that I'll just double check that my voice is very clear when we are taking the class. Can somebody reply that the voice is clear? Yes, yes. Okay. So I hope this 3V concept is very clear for everyone. So this 3V is very, very important. That's why I took some time for and make sure that you are understanding this 3V concept. If you want to learn this big data, this 3V concept is very, very important. This 3V concept has been identified or defined by the coin. This word is by IBM. There is a 4V concept is there and 5V concept is there. Okay. In big data, 3V concept is volume, velocity, and velocity. And then the 4V concept, we have volume, velocity, variety, and then value. What is the value we are going to create using this data? If you have 1 terabyte of customer data, using this customer data, what is the value you are going to create based on your business logic you are applied? So that comes into the picture of 4V, fourth V. Okay, so that's where it is coming to the picture. And 5V is the volume, variety, velocity, and veracity, and then value. These are the 5V concept also is there. So you can go through that in the upcoming slide so that you will understand better on that. So the introduction to the big data, where these data are processing. So for example, gigabytes level of data in your normal servers, payroll system, or sales inventories, the ERP and CRM platform, there the gigabytes level of data has been getting processed. The Web 2.0, advertisement, e-commerce, weblog, digital marketing, search marketing, recommendations, those areas, there are 2 terabytes level of data are getting processed. The clickstream, Wikipedias, blogs, sensors, devices, social sentimental, audio and video, for example, YouTube, they are petabytes of data. Okay, so this digital marketing feed, e-governance feed, Aadhaar systems, these are the petabytes level of data. Okay, the weather monitoring, text and images. So these kind of way, this petabytes level of data is getting processed. So these kind of data only we are talking majorly. Okay. So if you consider the data growth volume, in 2005 it's very less exabyte, and then in 2010 it is around a few thousands of exabyte, and in 2015 it's more than 8,000 exabytes of data in the universal. That kind of huge volume we are talking. Okay, the another problem is the Google file system, or the whatever the server what we are maintaining. In your normal company, what they'll do, they'll maintain a server, right? It's a client server concept. If you have the SQL server or Oracle, you have to do the processing with the SQL server or Oracle server. The server will be maintained in your data center, or it will be maintained in a separate room in your office where they will maintain all the servers, right? So these servers, if you want to store and retrieve the data volumes of terabytes, petabytes of data, it is very huge cost. If you are going for a normal hard disk, okay, how much of the normal hard disk cost? Maybe it's maybe thousands or a few thousands, right? Hard disk cost. Okay, if you're taking the 1 terabytes of hard disk, it's just 4,000 rupees. So how about the cost of 5 TB hard disk? Do you think 5 into 4? No, it will be differ, right? So 16,990. Do you have the, if you want to process the 100 terabytes, do you have the 100 TBs of terabyte size? No, it will be difficult, right? So you have to double that 5 TB hard disk, 16,000. You have to put that for 100 GBs of data to store and retrieve on the data volume. So for hard disk cost itself, it comes to 1 lakh, 2 lakh rupees to storing and retrieving, right? So instead of that, for example, 10 terabytes of hard disk. Here you can see 78,000. 1 terabyte is 4,000. That means 10 terabyte should be only 40,000 only, right? But here it says double the amount. When it goes to again the another 20 GBs or 20 terabytes, it will go very higher cost, right? So this data volume, when it is going keep on growing, scaling up, your data processing of GB level or terabyte level, petabyte level, it costs you more infrastructure point of view. Okay, so that's why the big data is providing a solution. No need to go for an infrastructure oriented database storage mechanisms. So it is providing a different solutions for how to handle this data. That's why it is very, very popular tool or very, very popular field in the IT industry. Okay, so we'll move back to the other concept. As I told you, there is a 4V concept. We have the large volume, velocity, variety, and value. So this value is in terms of extracting the business insight and revenue from the data. From the 1 terabyte of data, 10 terabyte data, what is the value you are going to create using the business logic? That's a 4V concept. So this is explaining about the from where and all these data are getting generated, and velocity, where this data are getting processed. And then variety, what kind of the varieties of data? It could be YouTube video, it could be text file format, or it could be Facebook content, or it could be exabytes of gigabytes of the CDs or files, storage mechanisms. And from wearable device, it can able to provide any kind of device oriented data processing. Those things we are talking. So another thing is called veracity. This veracity is the uncertainty of the data. So this veracity means what we are talking about. Based on that data processing, how we can able to trust the data. Okay, the trusting the data to making the decision making, the veracity comes into the picture. There is uncertainty of the data. Sometimes this data cannot be measured with the trustable format, or sometimes we can able to trust this data. So to apply that trusting factor, you have to apply the right business logic or the right mechanisms to make that out of 1 in 3 business leader, they don't trust the information because to use the decision making in the normal scenario. But if you're processing through the big data, the uncertainty of data will be very less, so that your data processing will be accurate and more based on your business logic. That comes to the veracity. The poor data quality will get a poor results. Okay, that's the kind of point it will tell you. So other thing is, we have to understand there is a new concept introduced by the Hadoop or the big data field, that's called MapReduce field. So this MapReduce field, we discussed about how Sanjay has created this MapReduce in the field of data science. So this MapReduce paper, white paper, you go through that, It is a simplified data processing on the large clusters. Okay, initially we found that there are 64 MBs of block where you can able to store and retrieve in the Google file system. Then he found that the map reduce concept where key comma value per concept you can able to store and retrieve this data. Okay, so this is the difference between a RDBMS and MapReduce. So in a traditional RDBMS concept, you can able to process the data size of gigabyte level, and MapReduce concept you can process petabyte level. So access is interactive mode and batch mode, but here the MapReduce model is a batch mode. So here you can able to read and write many times in the traditional RDBMS. In a MapReduce concept, you can write once and read many times. For the Hadoop purposely, only in Hadoop you can write once and read many times because we are doing a data analytical. And here structure is static schema and MapReduce is a dynamic schema. Integrity is high and integrity is low. And scaling is a non-linear. Here scaling is a linear. So that's the difference between RDBMS and the MapReduce. So these are some of the examples in the big data. Facebook is producing 40 billions of photo, and RFID is producing thousands of times of data as conventional barcode system. And then Walmart is producing 1 million customer transactions every hour. 340 millions of tweets is sending per day, and then nearly 4,000 tweets per second. And for example, 10,000 payments card transactions happening in every second, and every 30 minutes the Boeing engine is producing 640 terabytes of data for one flight of uh, Atlantic crossing multiple that more than 25,000 flights from flying from each day. Okay, so that's a difference of data we are talking about. So there are each field they have different varieties of data available that we are going to process. So next things we are going to understand about the Hadoop concept. There are these slides are just basic slide. I'm just talking about to a conceptual level of understanding. So I'm telling you about the big data. I hope it is very clear on the 3V concept, and then what is a Google file system, and then what is a MapReduce. So now we are going to talk about the other thing called Hadoop. Okay, the Hadoop we are going to talk about in the next 10 minutes. If you, any questions in the big data field, just ask me now. We'll take it for 2 minutes, then we'll continue over in the Hadoop side. You are unmuted now. We can talk anything. Any questions on big data? Okay, if no questions, we'll move back to the next slide. Okay, today we are going to the next 10 to 15 minutes. We are going to discuss about the introduction to the Hadoop, and then what is the Hadoop all about, and then Hadoop architecture, and then what is the MapReduce model. Okay, those things we will discuss now. So this also is another important topic in the big data or data analytical or data science field. It's a very important field. Hadoop is one of the topic which has been data processing for the large data. Okay, what is the name in the Hadoop? Is it any meaningful name for that? Why they put the symbol for elephant symbol for that? I'll tell you that story about that particular why it has been put across the name Hadoop. So the dog cutting, he's a person who has been creating the particular solution. Okay, in the year of 2000, there is a Google file system has been published. The white paper has been published, and then the 2004, 2003, it has been published by the Google file system, and 2004 it has been published by the MapReduce. 2005, there is no progress has happened by Google. So Yahoo also facing the similar problem in their search engine or search server. So what happens? So when they want to try the solution similar way, and they taken this white paper since it's a common public white paper. So they taken that white paper and then they done a further research on that. Okay. So dog cutting is the head of that particular thing. He's a basically lawyer. due to interest in the IT industry, he learned this Java and then he joined the Yahoo company and then he started working on that particular Hadoop environment. So based on that, so Hadoop, when he is created the version 1.0 in 2006 time, they are unable to pattern the name. So he's unable to put some name, and then through internet he want to trying to pattern the name. He's unable to find the name. So whatever the name he is putting, it's already available. So when he's playing with this child, 2 years old boy. So when he's playing with this children's, so he specified, okay, I have a toy. This toy, I put the toy name as the Hadoop. That son he specified. So he took that name as the, okay, it's like a fascinated name. So he took that name, and then based on that name, he put that name as the Hadoop. Hadoop is the meaning of that same elephant toy has been put across because it's a huge size. So they put a huge data processing. The same elephant symbol has been put as the logo for this particular software. So that's, but the maybe the name can be a kind of nothing specific, more specific, but the software which is more worth for the data processing field in the data analytical field. Apache Hadoop is a framework that allows for a distributed processing of large data set across the clusters of commodity computer. Okay, what is Apache Hadoop? Okay, Apache Hadoop is then a framework that will going to allow you to process very large data, terabytes of data, petabytes of data across the clusters of commodity computers. What is a commodity computer means? It is a normal home computer, home PCs or laptops. With using the normal laptops or computer, you can able to process terabytes of data. That's why this framework, like a Java framework, .NET framework, we have the .NET framework, right? .NET 4.0 framework or 1.0 framework or whatever the version you want to call it, and J2EE, Java framework, Hibernate framework. These are some of the framework is available, right? Similar way, big data field, Hadoop is one of the framework. That framework will allow you methodology of distributed processing of your large data. Okay, so but it can able to process in the normal computer because of the hardware infrastructure need to be reduce the cost. They have created the solution based on the it can able to run under the normal computer. Apache Hadoop is an open source software. It is available for an open market. It is a free to download, and then you can use the software. There is no license cost. The Apache history, it is started from the Google file system, published in the year of 2003, and then the MapReduce published in the 2004. Both the things we already discussed. So I'm moving to the next slide. Okay. The next thing is we have to understand more on this concept called MapReduce concept. Okay. The MapReduce, I told you, it's key comma value per concept. This map and reduce is going to work. Each and every Google file system or the Hadoop distributed file system, the data blocks is 64 MB block. Whatever in the blue color box, which is specified as the 64 MB block, each block is containing the raw data. So if you have 200 MB or 500 MB file, it is going to be split into a logical layer. From your hard disk, if you copy the file into the HDFS layer, there is a logical layer. Each block size will be 64 MBs of multiple blocks. If you have 200 MB, you'll have 3 to 4 blocks, you have the file. Okay. So here, this particular block size is 64. When you want to process, you apply for a business logic, this block will be distributed into multiple computer. If you are connecting 10 computer, you will get in a 10 computer power. If you are connecting 100 computer, you will get a 100 computer power. So how many computer you are connecting, that much of faster or reliability will be there for your distributed data processing. It can be anywhere in the location. It is not required that your computer need to be available only near to you. So each block will be distributed to the multiple computer. Each computer will be get processed, and then it will be going to return the result. It is going to reduce the result. If the business logic is not matching, then it will remove the packet from the data processing, and then it is going to process your data. Okay. In Hadoop core concept, we are going to talk about. Typically, it is a 64 MB of block size, and it can able to increase to the 120 MB block size also. So that is the block size of the Hadoop core concept, which you have to understand. The next thing is we are going to understand on the Hadoop concept and their architecture. Okay, in the Hadoop architecture, there are two things is available. One is the Hadoop distributed file system, and another one is the map redis concept. The Hadoop distributed file system, which is talking about the same Google file system, what it was described, but it is not in the distributed way, but here the Hadoop distributed, they put it as a HDFS. Instead of the Google file system has been emerged into Hadoop distributed file system. Then the map redis concept, this map redis concept also has been emerged to the Hadoop. They have created a logical engine for that map redis engine. Any data which has been processed, key comma value pair concept only, it is going to process. These two component, which is the basic component or basic platform for any data processing of your big data field or Hadoop field. So Doc Cutting, who is the founder of this Hadoop software, and he is currently co-founder of the Apache Hadoop project. So this is the Hadoop framework. This Hadoop framework is very important slide. We have to understand the Hadoop distributed file system is a logical layer which has been storing and retrieving your files, which has been 64 MB of block size. And then MapRedis framework, which is processing a programming model for distributed data processing. So here only your all the 64 MB block size of data will be key comma value pair kind of way it is going to process your data. The other tools are available, that's called Hadoop ecosystem, Apache Pig, Apache Hive, Apache Scoop, Apache HBASE, Apache Flume, Uzi. There are multiple 38 different tools are available in this big data field. Okay, so these tools, each tool will have their own requirement, they have their own functionality. So if you are become a Hadoop developer, if you need to understand at least minimum of 10 different tools is mandatory for you to understand. Okay, so which are the 10 tools it is useful for you, that you have to decide. I'll tell you which are the most popular tools which has been widely used. So if you focus on that, you can become a very soon, within a 3 to 6 month of time, 6 month of time, you can become a Hadoop developer. Okay, so there is a question from, I'm not sure, one second. There's a question from Arhint, so you want to some more explanation required for the map reduce concept. There is a further slide is going to come, so I'll explain that map reduce concept during that time. So now the Hadoop introductions, we understand that Hadoop introduction side. So we need to understand the objective of Hadoop. So the first thing is we have to understand, there is a slide talking about the what is Hadoop. Hadoop is a framework that allow for a distributed processing of large data set across the clusters of commodity computer using a simple programming model. You can able to process terabytes, petabytes of data using Hadoop framework that allow for a distributed processing of large data set across the clusters of commodity. What is the clusters? Clusters is the node. A cluster is a computer. Okay, it is in a server model. They'll call it as a portion of a server is a cluster. In one single rack, you have 16 server. Each server may containing 3 to 4 clusters. Okay, the Apache Hadoop is the open source software. You can just download the software from the apache.org. Other thing is we have to understand about the block size is 64 MB typically. You can also increase to 120 MB of logical block size. So other thing we have to understand this Hadoop component is Hadoop distributed file system, HDFS layer, and then the map redis concept. So these two layers is a very, very important layer of the Hadoop. You have to understand very clearly. And there are many other projects is based around the core Hadoop. There are referred as the Hadoop ecosystem. For example, it's a Pig, Hive, HBASE, Flume, Uzi, Scoop, etc. So these are the software called Hadoop ecosystem. Then the clusters is the individual machines are known as the node. Whatever the node we are calling as the, in the infrastructure world, they'll call it as a clusters. Okay. So then the Hadoop architecture, how this Hadoop architecture is working. So here there is a new methodology. It is not commonly how it is working like a SQL Server or Oracle. In a SQL Server or Oracle, you have the client server model. You have a client and server will be there. All the data are getting stored in the server, and then the server will respond back to the client. But in the processing of terabytes of data, if your server is processing and client is not processing anything, if you have only one server, then the server will be get hanged, right? So you cannot able to process large data in the server's perspective. So what we are doing here is in the Hadoop architecture, it is a master and slave concept. There is a one master that's called similar to our server, and then there is a slaves is the client. The number of client is called here slave. The terminology here we have to call it as a master and slave. The master node, which will be specifically will not process any data, only client will process the data, but the master node will send back to which computer need to get processed, which data packet need to get processed. It will create a name for that packet node, and it will distribute the to the multiple computers. Okay, then it will maintain if any result is returned by the client, then it will maintain a result of that particular data packet. Okay, so that's called master node. Other name called, we'll name it as a name node. The only job of the particular architecture is you can able to create a name for each block. So every time there is a block is created, right? I'll go to another slide so that you will understand more. Okay, for example, the data block, the name node, each block size is 64 MB. If you have a 200 MB or 500 MB of file size, it can be any raw file. It will divide it into BLK001. It's a one block, 64 MB block. Similarly, it is creating three different blocks. So another block is 64 of another block. Okay, another file is having different file size. So these blocks will be, the name node will create a only name for particular file. The master node is called as a name node that will keep track of which block make up the file and then where the block need to be located. It's known as metadata. It will also maintain a registry. For example, in a classroom, you have 100 students. If 100 students need to understand what are the names of the student, right? So similar way, each block, if 1 terabytes of file is created, that's 1 terabytes of file block. Each block will have an identity block ID, right? So that's a name will be generated by the master node, and it will maintain a metadata, which name node which is getting processed by the computer 1, which name node is getting processed by the computer 2 and 3, which has been returned the result. So everything will be within a millisecond of time. It will maintain the all the name node, and then it will be maintain the history of the processing the data. So that is maintained by the master node. So another few basic concept is HDFS perform the modest number of large files of millions rather than billions, and each typically 100 MB or more. So the HDFS perform best in the large file of data, and files of HDFS are write ones and no random writes in the allowed in the HDFS. You can only write only one time in the HDFS layer. You can also process your normal hard disk also, but it will not be processed very faster in the Hadoop manner. It will not process under the MapReduce model. You can also process your file system, which is file data available in your normal hard disk also. You can able to process the data, but it will not process a HDFS model. It will be processed under the normal model. If it's the large data which has been placed under the HDFS model, then the data distributed way, it will work in a very faster way. The HDFS layer, if you are having 10 computers, if you are connected, all the 10 computers should have the Hadoop environment. The master node will have a Hadoop environment, and client node also will have the Hadoop environment. That's called, if you have home PC, if you have only one computer in your home, then if you are installing the software in your home PC, then it's called single cluster Hadoop environment, single cluster node. Okay, if you have two computer or three computer, you are connecting it through LAN cable, and then you are processing your data into second computer and third computer using the IP address of that particular computer, then you are processing multi-node system. So it's a multi-node computer, multi-node clusters. So that's the difference between a single node clusters and then multi-node clusters. So typically each block size is 64 and 128 MB. The block size of replicated also 3 times. By default, each block will be replicated 3 times. Why they are putting 3 times replication? If any one computer is getting failure is happen, and then how to process your continuation of the other data blocks. Okay, for example, in computer 1, which is processing 3 blocks, same replica will be available in the computer 2 and computer 3. If computer 1 is goes failure, the replication copy will take into consideration, and then that will be going to continue the process. It will not going to re-begin the process. Okay, so that's a failure tolerance. So it is a assurance of giving the any data is processing under the Hadoop. There is a assurance is there. You can also increase to 10 times or 100 times also. Also, you can reduce to 0 times. If it is reducing to the 0 times, it will not maintain a replication. But Hadoop is saying that I'm not have the guarantee that your data failure is happen. I'm not assured that. It's up to you. You can increase but by default it will maintain a 3 replication. You can also reduce or you can also increase. Okay, the master node, which is called name node, that will keep track of the block name, and it is only duty is creating the name for the block, and it will send the name. Okay, the other thing is data node and name node, where you can able to store and retrieve these data blocks. So two things concept is very important. One is the master node and data node. The data node other name is called name node also. The other concept we have to understand certain things. I'll go through that. So there is a secondary name node is there. So secondary name node is not a backup of name node. It is for the different purpose to housekeeping the task for what are the data are getting processed. That's the secondary name node. First one is the master node, and second one is the data node, and third one is the secondary name node. These three things we have to understand. Okay, what is the data node? Data node is nothing but just your 64 MBs of block size. Each block size will be 64 MBs of block. Okay, so these are the understanding the concept of your name node and then the data node, how these data are getting processed in the HDFS layer. For example, this HDFS representation, your data file has been put into a name node. That name node will be data file will be broken into 64 MB of data block. That block will be transferred to the client machine. The client will be having a pre-replication of the same block. Then it is going to start your process of your through the map reduce manner, and then this data block will be each computer, each cluster will have the HDFS logical layer. So when it's getting processed 64 MBs of block size, it's going to process in a very faster way. That's a major concept of your Hadoop environment, HDFS layer and MapReduce. But there are large number of new concepts available. This is a basic concept I'm telling. Okay. Any questions on this? If you do, just ask me. I'll also explain you one more time this MapReduce stuff. Any questions on the name node, data node, all those things? Okay, there is a questions on the chat window. If my file size is 200 MB, one second, I'll complete this question. If my file size is 200 MB, my HDFS block size is 64. How it can be store the data? Okay, it's a very good question. If your file size is 200 MB, it is going to split into 3 different 64 MB block. So 64 equal to 128 MB block. Another 64 equal to another 64 equal to around 192 kind of block. Okay, so when it is processing your data, another 8 MB or 10 MB file which is going to process, which is only available as a 10 MB file, 10 MB block, and rest of the block size will be get removed from the memory usage. Okay, in your normal hard disk, if you have 3 KB block size, but you are going to store only 1 KB block. If you are putting only 1 KB, then the remaining 2 KB will be still occupied. But in Hadoop environment, it will not occupy your 64 MB of block size. It is going to release the memory block for the next block usage purpose. So if you have a 64, it is a fully 64, 3 blocks, and remaining whatever the file size is coming, that will make as a 1 block. So that's where it will maintain the block size. You can go ahead with the questions, please.
Excuse me, Manikandan.
Yeah.
I have one question. In a Google file system, they're maintaining as a 64-bit or something, some other number.
Okay, the Google file system, they put it as only the research paper, but they have not implemented. Instead of that, they have used a big table kind of way. The Google file system, they have not even implemented anything related to the Hadoop side. Yahoo only implemented by default their block size is 64, and then the version, first initial version, it is only 64 MB. Version 2.0, they have made it in a option level of 128 MB block size.
Okay, thank you so much. Google didn't mention the MB size in that in their paper. What kind of concept they are using?
Google specified in the chunk size is 64 MB by default, but they have not implemented the Hadoop environment in for their Google search.
Okay. Thank you so much.
Hi Manikandan. I have a question. What is the meaning of write once, read more?
Okay, so if you are normal, is it possible to update? You are talking about that, right?
Yeah.
Okay. What it is not like our normal application software development, right? So in normal application software, you will insert a table record, you will update the table record, you will select the table record kind of way. Here everything is already having the data which is been collected from the various other source. Okay, the various other source means you are going to get from the internet world, or you are going to get from the other server or any other data source mechanisms. It's going to collect the data, and you're going to put the data into your HDFS layer. So you're going to write once, you're going to read many times. The same 1 terabyte of data, what is the value you are going to create with that? What is the business logic you are going to apply over there? That's why you can able to, in the HDFS layer, you can able to write once. You cannot keep write means then the data will be keep change. There is no stable data, right? So that's why they made it now write once. You can write 1 terabyte data, you can write 100 terabyte of data, whatever the data volume you want to write, you keep it there in the HDFS layer. Once the beginning the process is getting started, you can read many times. The data blocks can be read many times for your data processing. But whether it can be updatable, yes, for certain things can be updatable, but not in the HDFS layer for the Hadoop, but in the other mechanisms in the Hive or HBASE, there you can able to update is possible.
So here, so Hadoop update is not there means, so duplicates will be there, right?
Yes, update in the see here the write once means you can able to write the 1 terabyte of data here on the HDFS logic layer. You cannot keep the change the data means again it is a writing once. You're removing the data, you're writing one more time.
Okay.
But in the Hive or HBase, it is under the top of the HDFS layer, hard disk is there. On top of the hard disk, we have the logic layer of HDFS. On top of the HDFS layer, they have another database mechanism. Like in SQL Server, you have the schema or table or database, right? Similar kind of way, the database are stored into the on top of the layer of HDFS layer. So there you can do the process of update and all in certain applications, not all the applications.
Okay.
So the concept is very simple. You have to write once and read many times because we are going to do a predictive analytical. Using this data, we are going to predict analytical. If you keep changing the data, then the new results that need to come. So you have to write one more time. Write once and you can read many times.
So Hadoop is one of the software, right?
Yes.
We can use as a big data. So what are the other softwares available?
So there are more than 38 different softwares available. I'll just go through that for a minute. So if you want to go through that, this Apache Hadoop will be there. So here you can go to the apache.org. There you can go to the big data. Under the big data field, you can see that there are multiple softwares available under the data science field or data analytical field. Each things will be useful for different purpose. Okay. So here under the big data, there are 37 different tools are available. So there are most popular tools we can say the Apache Storm, Spark, and then Scoop, and then we have Uzi, and then Flume we have used, and then bookkeeper Ambari we'll use, Avero will use, and then we normally use for other tools called Apache Hadoop will use. Apache Hadoop will be there in the database model. Okay, under the database, because it's a HDFS, right? It's a HDFS, so Apache Hadoop will come into the picture over here. Apache Hadoop, Apache HBASE, Apache Hive. So these are the multiple tools, 37 tools in the big data field, and then the database field you have around 25 different databases models, and the under the Apache database model. There you can see that only the selected databases are available for big data analytical field. Not for all these things, but most commonly the Apache Pig, Apache Hive, HBase, Apache Hadoop is the basic software, and then the all other systems are the ecosystem. Okay, so the ecosystems where you can able to see that you can download the software. These Apache Hadoop related projects are sub projects. Okay, the sub projects is Ambari, Avero, Cassandra, Chakwa, and HBase, Hive, Mathot, Pig, Spark, Test, Zookeeper. So these are the common tools we normally use for the most popular tools. Okay, the Hadoop common systems are available. One is the Hadoop distributed HDFS layer that is come from the Google file system layer. Because it is working under the distributed fashion, they may name it as a Hadoop distributed file system. Instead of Google file system, they change the name for copyright purpose. They put the Hadoop distributed file system. Then they have made the MapReduce, Hadoop MapReduce. These are basically the key comma value per concept. The data will be performed. Okay, the current version is the 3.0 version. You can go to the Apache hadoop.apache.org. Then you can go to the download session. You can download the software. Okay, here you can see that release. So this particular latest release is 3.0, which has been released under the 25th January, but it is started from the year of 2006 or 7 time, 2007, because 2003 the white paper has been published, and 2004 MapReduce white paper has been published, and 2005 nothing is progressed, and 2005 Doc Cutting is joined to Yahoo, and he started working on the Yahoo search engine in a better way. He stored and retrieved the first he tried to implement with the 100 computer of Hadoop cluster he created, and each 100 cluster size is 64 MB block size, and then he started putting the search processing data with 100 computers. It is successful, so he released a product in the year of 2007 with a release of 0.14 and 0.1. So from there this particular software has been growing, because they taken this concept from the Google. They cannot patternize this, so they have to put it under the open source concept. Okay, so these are the multiple version which has been released from the year of 2000. Last 10 years this particular field is emerging very faster and rapid way.
Okay, so big data, what is the difference between big data and data science? Both are same?
No, it's not a both are same. We cannot say it's a both are same. Big data is one of the platform where you can able to process the very large data, very complex data, right? But data science is one of the field. It's like a healthcare field. It's IT field. Similar way, it's a data science is one of the field. Under the data science, the big data concept will be one of the platform. Data science is very vast. Okay, the data science is like it's a field of data management. Okay, under that big data is one of the platform. Under the big data platform, Hadoop is one of the software. Most thing is the big data and the Hadoop, which comes under the data science field.
Okay. Thanks, Manikandan.
Yeah.
Thanks.
Any other questions to anyone? So another question here, there is a complete 200 MBs of files stored into a single data node. No, the data node which has been each block size is 64 MB block size. It will not store into a single data node or single computer. Each time it will going to process 64 MBs of block, and it will be distributed into multiple computer. 3 replication will be maintained by default. So each 64 MB, if your computer one is having your 64 MB data file, the computer will, Hadoop environment will decide when it is executing time whether I need to give the replication copy in the computer 4 or computer 5 or 6 based on when it is executing the infrastructure side, infrastructure, the availability, based on how it is processing. During that time it will decide where I need to store the replications. That's algorithm will decide. We no need to do any program for that. The algorithm automatically will decide. So another question here, how is HDFS and MapReduce is connected? How it has been HDFS logical layer is there and MapReduce is there. So both the things are placed in one single place. HDFS is the hard disk. How your operating system is connecting from your hard disk. Under the hard disk, you are storing your operating system. The operating system is start executing and then it is connecting with your hardware. Similar way, the logical layer of Hadoop software, where the software which has been specifically, you can download this software. This software will be available in the zip format. You can download this particular zip format from the source. So this star file you can execute. The star can be executed in the Linux format. Okay, you can just, it's like a zip format in the Windows, tar format is in the Linux version. Okay, these are the ways you can able to specifically you can put that software. But how it has been get connected? This HDFS and MapReduce is both are software. Okay, HDFS is one of the software, logical software, and MapReduce is one of the algorithm of engine. So both are interlinked. Any data which is going to process, the data packet which is coming from the, it's like a data layer. The MapReduce is the one of the engine where it's going to process your data packet in the HDFS layer. Okay? So that's where it's getting connected. Both are in the same place. So another thing is, if we updated in the top layer, the data in the HDFS layers should change. I'll mute this. I'm sorry, I have to mute this. But I'll go through the questions what we have this particular thing. So the question is how it has been interlinked with the Hadoop and then HDFS layer. Both are software, both are in the same framework, Hadoop framework. Both are interlinked in the Hadoop framework. Both software will run when you're executing the program. HDFS layer will store the files and MapReduce engine will be take the file and process your data node. And then other questions we have, if we update the top layer, the data HDFS layer should change. I'm not really get the question. For example, based on my understanding, if you are having a hard disk, under the hard disk you have the 100 MB of file. That you're copying that 200 MB of file. That you're copying the 200 MB file into a HDFS logic layer. You are using the same command. How you are using the copy command in your DOS prompt, how you are going to copy that. Similar way in your Linux environment, in the terminal window, you are going to copy the file into HDFS layer. Okay, the same kind of copy command. The copy command, once you've done that, if you're changing any data in the hard disk, it will not reflect in your changes in the HDFS layer, because HDFS is the another logic layer of the hard disk. Whatever the data you are processing, you are storing, it will not change anymore, because write once, you can read many times. If you update the top layer, you cannot even update in the HDFS layer. If you are updating, means you are removing that file from the HDFS layer, you are putting a new file. So that's where you can able to write once and then read many times. So other thing is, what is yarn? That's a very interesting question. What is yarn? Okay, so we'll go to that slide. It's a very interesting question. What is yarn? Okay, so this particular slide will talk about yarn. Okay, the first version, Hadoop 1.0, which is having the HDFS layer and MapReduce layer. Only two components is available. In Hadoop 2.0, the HDFS, yarn, MapReduce and other data processing tools are available. Okay, the HDFS layer is basically store and retrieve the data logical layer, and MapReduce will be processing your key comma value pair concept of engine. These two things are programs. Two things are components. If you want to distribute data processing, how to manage the resources, how to manage the RAM, how to manage the particular computer size, or how to manage the number of computers connected, or how it has been getting processed. What will happen if one computer is getting failure? So those things previously in Hadoop 1.0 version, those are a smaller level of library files which has been managed. But when it's growing the software, the Hadoop 2.0, they created another layer, Yarn, as a separate layer where it will maintain the clusters resource management of your distributed computer. So HDFS layer, and it is going to manage your all the computers under the top of the MapReduce data processing engine will work. Then the other data processing tool like a Pig, Hive, HBASE will be combination of all the tools are Hadoop ecosystem. So that's the architecture of your version of the particular 1.0 and then 2.0. You can check that in the particular software, where in the 2.0 version, when it's coming to the picture, the yarn will become into your factor. Okay, so this Hadoop yarn, this particular yarn will come into picture from the 2.0 version. You can check over there on that particular release. Okay, in the 2.0, which has been released in the year of 2012, yarn as the next generation of the managing the cluster resource side. Okay, so that is the major thing which has been performed over there. Okay, so this particular thing, Apache Hadoop Yarn, is the yet another resource negotiator. This negotiator, what it will do, it will manage your clusters resources. What is the cluster's capacity? What is the cluster's storage mechanisms? How much of the hard disk space is available? How much of the RAM speed is available? Those things has been maintained through the Yarn. Yet another resource negotiator. If you want to process 1 terabyte of file, so if you have 10 computers connected, 5 computers is more powerful and another 5 computers is less powerful. Okay, then the yarn will decide where this data need to be get processed. That engines are working through the negotiator. Okay, one data is getting processed by the one computer. So every 30 millisecond of time there is a heartbeat will come. Okay, from client to from slave to master, I'm still processing. If any failure is happened, this yarn will decide where this need to be computer need to be moved. So all the infrastructure related servers of computer resources are managed through yarn. Okay, for a data processing alone. So another question is, does MapReduce change the data in the HDFS into key comma value pair? Yes, that MapReduce engine will change that. All the data will be getting processed through the methodology of key comma value pair concept only. Data stored in the HDFS will not be key comma value pair. The HDFS layer will be in a raw data of 64 MB sub block size, but when it's taking the block and then when it is getting processed through MapReduce engine, that time the key comma value pair, the key will be generated, and then the value will be your 64 MB sub block size. Each value of 64 MB will be split into multiple chunks of data. For each and everything, so again it will be put a key and value pair. So till based on your business logic, it will be process your data as a key comma value pair concept. Okay, so this is the full architecture of your HDFS or Hadoop 1.0 and 2.0, and Yarn, it's a cluster resource management tool. Okay, we'll move on to the other concept. So before moving to that, I'll re-explain that what is Hadoop HDFS, then what is Hadoop MapReduce. As I told you previously, the MapReduce concept I'll explain you in detail, so that is a very important concept in the Hadoop side. So Hadoop architecture, we know that there is an infrastructure is running the computers, then master node is slave node, the slave node which is the multiple computer. So each data block is green color box, 64 MB block. Each yellow color box is the computer, this computer will be work as the clusters, okay, or server or a group of computer. The group of computer is rack. In a normal ITL server data center, 16 computer is called one rack. In a one single rack, you can see that in the if you are searching any ITL infrastructure of data center, just type data center. You can see that there are multiple computers will be available, right, in the server. In the server room, you can see that multiple computers are connected. So if you are count this number, each rack will be have 16 racks will be available for each server. Okay, if you want to see that data center, you can see how the Google data centers are maintained. So this is a Google data center which has been maintained by the multiple servers. Okay, so these multiple servers are every minutes, every second, which has been getting processed your data across the world data, which has been getting processed. Okay, so this is how look like a big data center, where the each and every time the hard disk capacity they will change, the memory unit will get processed, all your data are getting processed. There will be cooling methodology will be there. That's ITL, they totally IT infrastructure side. So this is your data center. So each data block size will be having the clusters. Each computer will be connected one to one of networks, and then there is a rack will be there. These racks will be managed by the data center. Each rack will be 16 clusters. Okay, so that's called rack. These rack can be, one rack can be in India, one rack can be in US, and then one rack can be any locations. So the name node, which strongly advise that, which is little higher configuration, and clusters can be any kind of data, any kind of computer configuration. Okay, the other thing is we have to understand how to install this Hadoop. To install Hadoop, it is strongly advised that you can go for an Ubuntu software. It's an open source software, open source operating system like our Windows. You can download this software from the ubuntu.org and download desktop. So the step-by-step guidelines, it is already available under the file section. You can go through that, and then you can download the versions, any version, and start installing that in your hard disk. When you are installing the hard disk, always ensure that you are installing in the alongside of your Windows 7. If you're having Windows 7 or 8, if you want to install, then choose the option install Ubuntu. If you are replacing the Windows 7, then Windows 7 will be get removed, and then Ubuntu only get installed. So always install Ubuntu alongside with Windows 7. So once you are installing that Windows operating system and Ubuntu operating system, Ubuntu is an open source operating system. Windows is a license-based model of graphical user interface of operating system. This is also graphical user interface only, but it's open source software. So there you have to just start installing, choose your computer and then hardware, whatever things, and create a login ID. Once your login ID is created, the installation will be run, and then the installation will be get completed in 5 to 10 minutes of time. So once that is done, you have the choices of the Ubuntu you want to go or Windows 7 you want to go. So once if you choose the Ubuntu, you will get a login ID and password. Once you get that, this is your Ubuntu similar to our Windows screen. So there you have to choose the terminal window, which has been available in the start button. So there you can choose the terminal window and start using the unzipping the Hadoop software and then installing the Hadoop software. You can find the step-by-step guideline under the file sections. So next thing is, if you want to use the same software in the Windows environment, then you have to go for the Oracle VirtualBox. Through that Oracle VirtualBox, you can able to download and install your like creating as a virtual machine, creating like a virtual clusters on your on top of your Microsoft Windows OS. You can download the VirtualBox and you can mount the Ubuntu operating system. Then you can start working under the Ubuntu under the your Windows operating system also. So to download that, previously oracle.com, now the Oracle virtualbox.org, you can download from that particular software from that particular URL. Then start installing that under the Windows environment, and then you can just mount the software through the new, click the new, then you can choose the Ubuntu. Then the Ubuntu ISO file need to be downloaded. This ISO file need to be get mounted through the virtual machine. Based on the virtual machine, you can create your hard disk size and then the gram size, how much you are going to share with that operating system. Then you specify that. Then once you specify, your Ubuntu will be just mounted. Based on that, you can start working on that, run that mount. Then you can start using this Ubuntu on top of your Windows. So then we have to understand, we understand the MapReduce, how things are working. So here we are going to in detail, we are studying about little bit about the MapReduce program. So the MapReduce concept will once again we'll understand how this MapReduce are working. So the MapReduce are your input file, 64 MB of block size will be split into multiple smaller 64 MB of file. That means the input will be split into multiple key comma value pair concept. Each key comma value pair will be compared with the another key comma value pair of your data and apply your business logic. Okay, so in between you have the in between sorting, shuffling, partitioning, combining, everything will be that MapReduce engine will perform for your data operations. So if mapper and reducer will process your large data of 64 MB of block size within a key comma value pair, each key comma value pair of 64 MB will sliced into multiple key comma value pair, and then it will be compared with the one block with the another block. Based on that, your business logic will be get applied. So then reducer what it will do, it will be perform your output file, and then it will be produce your final result over to the output file. So there is standard input file format. As I told you, it's a structured, semi-structured, and unstructured data type. You can able to create any kind of data type file format. That's why it is most popular wanted software in the IT industry. For example, if you want to give in Java or any other platform, if you want to write a program, you can use this basic input file format, file input format, text input format. If you want to put a unstructured data or semi-structured data or kind of structured data, you can use this key value text input format and sequential input format. If it is a raw data, you can use the sequential file input format. Sequential file as text input file format. So these are the different varieties of input file formats are available to put your input for your data blocks. Okay. So a normal objects in the Java, you can see that integer, float, double, all those things, right? These are the integer creation or float creation or double creation, right? But in the Hadoop environment, for writing a program or writing a MapReduce program, you have to use the all the objects which is the writable. Okay, for example, int writable, long writable, float writable, double writable. For text, it is a string. Text for string. So these are some of the boxer classes available for writing the defining the variables. Okay, int writable for integer, long writable for long, float writable for float, double writable for double, and text is for string. The input file format can be either file input format or text input format or key value text input format, sequential file input format, or sequential file text input format. So these are the way you can able to process your data. So for writing a one MapReduce program, you need to write a 3 different stages. One is the driver code and mapper code and reducer code. What is a driver code? What is a mapper code? And what is a reducer code? The driver program, which has been basically used for your how to drive this program of a end-to-end. Okay, so there you can write a program if you want to write a word count program. So this is written under the Java. So here you can first define your library files of Hadoop. Then you can define a class. Based on the class, you can create a new job as a word count. Then you are giving your input file format for the where the Hadoop HDFS layer the data files are available. So under the HDFS layer, the input file you are giving as a file input format. Set input path. This input path will be your HDFS layer path. Then file output format, you are writing under the output file format. Only the output file you are writing. and then the mapper reducer, you're creating two classes. One is mapper and another one is a reducer. There only you are applying your business logic. What is the operation you want to perform using this data file. Then you are writing your output file format. So there output also key comma value pair, input also will be processing as the key comma value pair. Input file as a raw data, and then output file will comes into the key comma value pair. But in between these data processing, the mapper and the reducer, the mapper engine will be get processed through key comma value pair concept. So here I explained you step by step, line by line, how to write a first program. So here the import, the defining your Java or Hadoop algorithms or Hadoop libraries, you can import that. You can copy under the Hadoop environment library files. You can put the file into Eclipse software. Through that Eclipse software, you can easily write. So then you are writing your class file word count. Through that word count, you are just giving an input file and you are putting the output file. This driver file is defining the how the structure of your program need to be run. Job client dot run job will be run execute your program. The second one is the it is clearly defining if somebody doesn't know Java. For the purpose of for them, I explained in how to create a class file. So line by line I explained. So you can just go through this video or my previous video where you can able to understand what is this all about of this program. Okay, how to define what is the if statement, what is the conditions we have to write, and then what is the job contract, how to create that. Everything I explained in detail. You can go through my previous video to understand this particular program. Okay, so next thing is we have to understand the word count. Word count is one of the program. So there we have to understand the other things, how it is going to write. One is, so far we studied about the one is the driver file. Now we are going to understand this whole thing is driver code. Then we have to understand the mapper class. The mapper class only will map the value, key comma value, right? How it is need to be get mapped. So here long writable as a text, and then int writable as the integer. How many words which is available. So what it will do in a file, you have 200 MB file, you have a raw text of multiple words. For each word you are splitting into white space. It's a paragraph. The paragraph containing multiple words. So what it will do, first it will split into multiple 64 MB sub block. That block will be again multiply, again it will put into key comma value of the block. First it will generate a key value for a particular block. Then that block will be again split into multiple key comma value based on the number of word is available under the block size. 64 MB block, if you have 1000 words in the particular 64 MB block, 1000 lines, again it will put into 1000 lines of key comma value pair. Again if you have the 1000 words available inside that particular block, then it will put the another 1000 key and 1000 values. Each block, each word will be get mapped within a key comma value pair way. Again this key value will be compared with the another block of another key value, another word of that particular key will be get compared and the value will be get compared. That's the kind of concept is key comma value pair. Within a millisecond of time it will be generate multiple keys and multiple values will be get mapped, and then it will be going to process. The key and values are matched with the one block to the with another block, then it will consider that block is matching. If it is not matching, then it will go for reducing. Then it will remove from the operation. If you have 1 terabytes of hard disk space, 1 terabyte of raw file you are giving for your data operation, then what it will do, it will not go into process of all your 1 terabytes of data. If the key schema value pair is matched for in the block of 5 and 10, we will consider only the 5th block and 6th block. For 10th block will be just take that is only the input file block where it's been compared, and then the output will be get reduced only between this operation will be going to happen only between this 5th block and 10th block. So that's where it has been processed. So I'll just unmute that for a moment so that if you have any questions you can ask me on this. What is a driver and what is a mapper? Then the reducer, I'll explain you the reducer, which is nothing but how to write a output file. So everything will be specifically in the key comma value pair concept, the data will be get right. Each word will be specified, and then this reducer program also similar way. It is just writing your for loop concept. You are just putting a for loop for how many words are available. You are just incrementing the value to get the value based on the number of words. If two words are matching, for example, I'll go through that example on that so that you will understand more clearly. Here, in a Word file, input file format, you have the key 3414. This is a paragraph. Under this paragraph, you have 4 to 6 words. The cat sat on the mat. So it has containing these 6 words. So each word will be again put into multiple uh, key comma value per kind of concept. Here this THC is the key and then value is the 1. So same data block, similar to this computer 1 has one data block, similar to that computer 2 might have another data block, have the similar kind of key comma value pair which has been splitted. This key comma value pair will be compared with the another data blocks of another key comma value pair. If THC is found on the block 1 and block 2, then it will be merged together, sorting, shuffling, combining things will happen. Based on that, it will be combined and then final reducer will work. The reducer will do TH is found 4 times in the 4 different blocks. So the count will be exactly coming how many word count is performed into the all the data packets. So this is how this key comma value pair concept is working. Okay, any questions on this?
Hello, Manigandan.
Yeah, please go ahead.
I have a question. The map program is like that, business logic applying on creating a summary from the data. Is it correct?
No, okay, can you redefine your question, please?
Just like we are creating a summary table from a large volume of data.
Mm-hmm.
Is it like that? The mapper will do like that?
No, the mapper thinks what it will do. It will map the key and then value pair. It will generate thousands, lakhs and lakhs of key and then lakhs and lakhs of value. If your raw data is having multiple values based on your business logic, if you are having any data packet it is generating, any data is which is getting processed through the mapper will be create a key for each and every word or each and every data block. Based on the data block, this data, for example here 3414 is a random generated key value. There that value has been specified of that particular 64 MB sub blocks. Okay.
Okay.
Another 3437 is another key and then another 64 MB block. So if it is 200 MB file, there could be multiple input mapper. Okay, each block will have only one mapper. Under that mapper, you have multiple data packet. The data packet will have another key comma value per concept the mapper will drive. THE is another word that will be considered as the key and then value will be 1. So how many times it is being repeated, this business logic will apply over here.
Okay, fine.
Okay, the key and value pair concept will keep on repeat multiple times. It is split into multiple key and value pair concept. It will work.
Okay, thank you.
Okay. Anybody has any other question?
Hi, Maninu. Hello.
Yeah, please go ahead.
Hi.
Yeah.
Is it any other way to write a program like a Python, any other language? Is there a way to only write a program in Java only?
No, it's not like that. Java is most widely used for Hadoop programs. Hadoop also written in Java, so it is advisable used for Java, but it is not a constraint that only Java is able to write the code. It is can able to process any kind of language. It can support multiple language. Python also is possible. .NET is possible. C++ is possible. Most of the other languages also is possible by this writing the Hadoop program, but it is advisable to write in the Java program. But Python is most popular nowadays. That is also possible to write a Hadoop program.
Thank you.
But if he doesn't know the Java, it's not at all a problem. Okay, it's not at all an issue. The other software like a Pig, Hive, HBASE, or whatever the software we studied in the particular field, the Hadoop projects, right? The Hadoop projects based on the category. I'll let it get loaded. So here you can see that there are a lot of tough softwares there, right? These softwares are not required for Java for all these things. Example, Apache Pig. Apache Pig is the Latin script language. Normal your English language is enough for writing a program. Is not required for a Java at all. Apache Hive, Apache HBase is not required for a Java. It will just require your basic SQL Server command. There are basic SQL Server statement is required for writing the Hive program, HBase program, right? So these are programs will be again converted into a MapReduce program automatically by default when the compiler will convert your Pig program or HBase program or Hive program, whatever the Hadoop ecosystem programs tool, whatever you're writing, that again will be converted into a MapReduce program and then it will execute. The compiler will convert your statement or your programs will be converted into MapReduce engine. The MapReduce engine compiler will convert into a MapReduce program, then it will execute that into the HDFS layer. Okay. So Apache Pig is the one of the high level language which is not required for an Java related. So it's just a Latin script language where you can able to simply write the load. If you want to load a file, just specify load. If you want to save the file, save. Simple commands. The normal English. You can do the all the operations what you want to process. The word count program, it is just two liner for the Pig lines, Pig commands. So one liner for your HBase. But in Java you write hundreds of lines for that. But it is for the different purpose. Okay. So some of the interesting questions posted in the chat window. We'll discuss a few things over there. If you build a 10 node of Hadoop cluster, do we need to install Hadoop on the all the nodes? Yes. If you install 10 different nodes, you have to install the all the systems. You have to install the multiple system you have installed. Then you have to put a different computer. You have to all the computer you have to install the Hadoop environment. Okay. So I'm just go through that certain videos I'm going to run for a minute. So for a better understanding how to configure your multi-node clusters. Okay, you can see my screen under the YouTube video where you can able to. I'll just put the particular video where you can able to once again. We will take a look at them once. Okay, so here you can see that Hadoop master and slave. This master node will be your first computer where you want to make that as a server. So once that particular thing you are setting up of your Hadoop software where you are installing, downloading and extracting all the files on the first computer. So once you are configuring, there is a configuration system is available. In the configuration system, you can see that each computer will have their node, name node. This name node where you have to configure. How to configure is in the command. There's a configuration file. You have to specify the path of the detail, and then these configurations already I specified in the our step-by-step guidelines of how to install the software. So here, this particular thing only I want to show. So each computer name, each computer will have their IP address. IP address of 172.23, 178 or 130. Each computer will have their own IP address. This IP address need to be specified. Based on the specification, you can able to connect the multiple 10 computer means you have to specify the 10 different nodes of IP address of that particular that configuration. Maybe I'll help you out for installation time. You can do the installation of multi-cluster node of environment. Clear on this? Any questions? Okay, we'll move on to the next slide.
1 second, Manikandan.
Yeah.
What is the recommended cluster size? Minimum.
Cluster size means it should be one cluster, right? So if you are connecting with the one computer, it's a single node cluster. If you are connecting 10 computer, it's a multi-node cluster. If you have two computer means it's multi. Two computer means multi-node. You can connect 10 computer means it will be 10 computer power. You can connect n number of computer also based on your capacity, based on your volume of size, what you are going to operate.
Okay.
To perform the Hadoop in a distributed way, it should be a one single computer. It can be your normal commodity computer. Normal your home PC is enough to process terabytes of terabytes because it is distributed way. It will process map to this concept. It will process 64 MBs of block size. That's why it is able to process terabytes of terabytes in a very faster way. If you're connecting 100 computer, it will give the 100 computer power. If you connect 1000 computer, it will provide you the 1000 clusters of power. So it will be very, very faster to data processing for terabytes of level of data. So now we'll move to the other next topic. We'll understand there are so many other topics we can study. I'm giving the basic introductions of each area, but when the training time or maybe the full-fledged corporate level training what I'm giving or the corporate level training will be each topic will be it's around a one full day session. Okay, that kind of way it will be a kind of that much of lot thing is there to learn on that, and then there are each session will have the practical oriented sessions. All those things will be get into the picture. Okay, so this Hadoop HDFS distributed layer, then MapReduce, that MapReduce programming itself an half a day or 1 day of program sessions where you have to write many sample exercise program, and then you have to understand all the keywords and then syntax for writing the programs, all those things. HBASE and Hive or Mathod or Pig or Woozy, those things, all these things have the practical sessions, and then we have to write the syntax of each and every line, and then understanding the compiler model and understanding how to write a program over there. Those many things will come into picture, but I'm giving the first intro level for everyone for in a pre-session class. So next things we'll understand about certain today's topic, Hive or HBase. Those are not available. I have more than 2,000, 3,000 slides, so I'll just go through a few things for now. Where I kept it. Okay. So these are proprietary slides. I am just sharing that. Okay, so far we understand about the Hadoop, big data, and then we studied about something called HBase. Sorry, we studied about MapReduce, HDFS layer, those things, right? So now we are going to study about a little bit understanding of the what is the Hive. Okay. So today we are going to talk about more onto the Hive. So before moving to this topic, do you have any questions? Do you have any questions on understanding of big data? Do you have any questions on understanding the concept of 3V concept or 4V concept? Do you have any questions on MapReduce or HBase? Just please tell me the questions. We'll understand.
Hi, Manikandan.
Yeah, please go ahead.
May I ask a question now?
Yeah, please go ahead with your question.
Actually, I need some clarity in that. I am saying my understanding is understanding to you. It's please verify my understanding.
Yes, please go ahead.
First of all, we just put our data in HDFC file system. After
Yes,
after putting our raw data or semi-structured or semi-structured data in HBASE file system, we are applying the map reducing algorithm. Once a map reducing once applying after applying the map reducing algorithm, which is written in any language, the structured the raw data is converted into readable format, or only the required data is available in HBASE file system. Is it correct?
No, it's very partially only correct. I'll reformat
Okay.
that the understanding. So
Okay.
initially you have the data. The data can be raw data of your hard disk. In your hard disk, you might have a 500 GBs of hard disk, and then under the 500 GB of you are having 200 GBs of hard disk raw data of customer data you're having for data processing. This 200 GBs of hard disk data, you can dump this into the HDFS layer. Okay, you can using some HDFS layer, the copy command. You can copy the 200 GBs and write once in the HDFS layer. So these block size, which has been copying and copying the data from the hard disk to the HDFS logical layer, each block size will be 64 MBs of block. The map reduce algorithm, we no need to write any program. It is automatic in an engine. That engine is a component available in the Hadoop software, and then the HDFS layer also is a component which is already available in the hard disk. These two things are two different components which is available already. We no need to write any program for that. And second thing is, if you want to writing a Java program, there what you are writing, you are just giving your input file, you are writing your business logic, and then you are putting your output file. So these three ways you are just organizing your data, where read from the input file here, and then process your business logic there, and then you write the output file here. Internally, the Hadoop software will work and it will perform based on your data processing business logic. The algorithm or the engine, the MapReduce engine will execute your data processing. This MapReduce engine, where it's going to process, it is going to process in the multi-cluster or multiple computer is going to process. Each block in the HDFS layer will be replicated in the multiple clients three times, and then this data processing will get started. The master node will maintain the history of all the data blocks, and it will create a name node. Based on the name node, it will maintain a metadata, which computer 1, which computer 2, computer 3, computer 4, where the data blocks are getting processed, which computer 1 whether it is a computer 1 is completed the data operations, whether can able to write the reduce operation, or those things will be maintained by the master node. The slave nodes are, it's a client node, those are processing your data, but in server node you will just maintain your where the data are processed. It will create only the name and it will maintain a metadata. But the MapReduce engine is the inbuilt algorithm where it will be execute all your data process under the key comma value pair concept. Each and every 64 MB blocks are value, and then for each and every 64 MB there is a key value will be specified. Internally, after the key current value, there could be multiple key value pair will be get generated. Each and every word wise, till the output is matching, till the business logic is applied, the each and everything will be split into multiple key comma value pair of data operations.
Yes, Manigandan. From your replying, I get some clear picture in this.
Okay.
Thank you so much.
Okay. Anybody has any question? Yeah. Okay, let's move on to the next topic. If you doesn't have any question, if you have any question, please ask me in the chat window.
Manikanta.
Yeah, please go ahead.
Manikanta, we are installing Hadoop 10 nodes.
The voice is very low. I cannot able to hear you. Can you come to the mic?
Yeah, I'm on mic only.
Okay, Kader, yeah, please go ahead, Kader.
If we build 10 nodes of Hadoop cluster, am I audible?
Oh, you're a little bit audible only. Can you write the question in the chat window?
Yeah, just a sec.
So while Kader is writing the questions over there in the chat window, if anybody has any other question, please post over to me. Hope you now understand what is big data, introduction of the big data, introduction of the Hadoop, who found this Hadoop, what is the Google file system, what is the HDFS layer, and then what is the MapReduce, and what is Hadoop, what is the different types of data node, name node, master and slave concept, all those things, and then MapReduce engine. Those things, I hope you are aware of that. So Kadar's question is, if I have 10 node cluster, each node has its own MapReduce. These are communicated when fetching the data? Yes. It will communicate it during the processing time. Okay. Each computer will have their own map and reduce. Each computer will get processed 64 MBs of block. Each computer will be having their own MapReduce. That MapReduce will be get processed. That MapReduce will be getting processed over there. Each computer will be have their own MapReduce. The key command value pair process under the computer 2, computer 3 kind of way. The map and reduce engine will work for that. It will be get connected. It will be connected with the all the nodes. Okay. So now we'll move back to the next topic. It's called Apache Hive. So Apache Hive is the one of the important software tool in the writing the programs. For example, the Facebook is written through the Apache Hive. The data operations which is performed through Facebook and all through the Apache Hive, the data operations are performed. If you go to the Google's site, and then if you put the Hadoop ecosystem, you type, you can see that what are the various tools, what are the various softwares are available under the each layer. So these are the multiple tools which has been specifically for your Hadoop environment. Okay, so here you can see that what are the major tools are available under the Hadoop ecosystem. But under the Hadoop ecosystem, this particular thing is HDFS layer, and then MapReduce is the basically two layer. It's a two components called Hadoop, HDFS, and MapReduce Yarn. These three layers is called Hadoop. All other things, HBASE, Hive, Arconnect, Method, Pig, Uzi, all the things are comes under the Apache ecosystem. These are sub projects or sub tools. On any tools, whatever you are processing, either through Method or Spark or Solar or it's Pig or HBASE or Uzi, anything will need to get processed and need to be get processed under the Yarn. It need to be get processed under the HDFS layer. It need to be get processed under the MapReduce engine. This layer only is going to process your all the data. Okay, without that it will not going to process any of your data, or whatever the data, either it could be Pig or Hive or HBASE or Cassandra, or whatever the data you are getting processed, it need to be get processed under this HDFS layer and MapReduce engine and then Yarn. These things only it is going to process. Okay, so Apache Hive is one of the tool you can able to understand very easily. If you know aware of the SQL server, it is very easy to understand. It does not require a Java language. Okay, so Apache Hive is one kind of data warehouse infrastructure built on top of. It is providing the query language. Hive is one of the query, like a SQL query we have, right? Similar way under the Hadoop, you have the HQL, HiveQL. Hive is one of the tool where you can able to process large data, terabytes of data into the ETL structure, and then it's purely a database oriented analytical tool. Hive is one of the data warehouse management tool. It is similar to SQL Server. SQL Server, if you are familiar, you are very easy to process your data. Okay, so it has its own structure, but it has its own structure of your data processing. Okay, now we'll introduction to the Hadoop. The Hadoop is the one of the data warehousing type of solutioning for your managing your large data in a structured way. Okay, here Hadoop is it's like a database. Hive is one of the similar to a query language where you can able to write a query and then you can export or import, or you can do a data operation through the SQL server using the SQL server, similar kind of query language. You don't need to write a Java program. Whatever the query you are writing, those query will be converted into a MapReduce program internally by the compiler of Hive. Based on that, it will execute under the HDFS layer. So Hive is the SQL-like ad hoc query language. It has aggregation and analytical of huge volumes of data. The SQL server normally processes 2 terabyte or less than terabytes or gigabyte level of data. Of you can able to process 10 lakh record or 1 million record or 2 million records of data. But here Hive is going to can able to process of terabytes, petabytes of levels of data using the Hive language. So here the Hive is the cost-effective data solutioning management. It is a MapReduce it is always processing and executing through the MapReduce execution. Then always the data will be get stored under the HDFS layer. Okay, and also the Hive language will have the connectivities of external and internal database management system where you can able to call through JDBC or ODBC access is available, where you can able to export or import the data processing from your existing data tables. It is fully extensible. Okay, first we'll understand about what is Hive and then how to write a program, basic programs, how to write, and then we'll start studying in depth in the subsequent classes. The data warehouse is built on the top of the Hadoop. The Hive is the data warehouse tool where you can able to, which is available on top of the Hadoop, and it is providing a SQL-like interface where you can able to analyze the data. Through this analyzing data, you can do all the data analytical activities. Hive is an open source under the Apache. You can download the Apache open source software from the apache.org. This work in the high throughput, high latency principle, same as Hadoop. How the Hadoop is working, similar way only Hive also is working. Ability to plug in the customer MapReduce program. So it will be convert your existing program into a MapReduce program based on the compiler. Mainly targeted for a structured data. Hive is a purely oriented for structured data. And it is hide the MapReduce program when complexity is end user. So you cannot able to observe that how the program is running, but when it's executing the query, then it will be converted into a MapReduce program of key comma value pair kind of way. Then it will execute into this MapReduce program under the MapReduce engine. So this is a Hive architecture. The Hive architecture is basically which has the Hadoop, environment. Under the Hadoop environment, there is a MapReduce. Under the MapReduce, there is HDFS layer will be there. Then it has been connected with your Hive sub-project. In the Hive sub-project, you have the Metastore. The Metastore is compiled within a driver, compiler, optimizer, and plan executor. There is the Hive Threat server. That Threat server will be connected to your database connectivity. So there is a multiple data source you can able to connect through the for the parallel processing kind of data. And there is a web interface and CLI will be there, command line operating system. Through the terminal window, we can connect to these drivers of Hive. Then you can able to process your MapReduce or HDFS data source where you can able to process your data. So Hive is a similar SQL like query ad hoc query language that will be producing, aggregating the analyzing the huge data. So SQL like query, that's why it is called as a HiveQL, 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 like a SQL structure query language. Here we are calling as a HiveQL. Okay, so it is based on running, executing through the MapReduce execution. Hadoop distributed file system is the Hadoop working under the HDFS storage mechanism. Now we'll understand more on the Hadoop architecture, Hive architecture. It has the 4 components. The majorly 4 components are driver, Metastore, interfaces, and thrift server. These servers are architecture of your Hive. Okay, how to write a Hive program? So Hadoop environment is containing the HDFS layer and then MapReduce layer. Then it will be Hive language where you can able to process your data components. This is another tool. This tool is containing it won't components, it won't structure. Based on that, it will execute. The Hive introduction, SQL like ad hoc query language where you can able to process of huge language. This slide we already discussed. I'm moving to the next slide. Okay, from where and this particular Hive is used? For example, social media, big insight, analytical. During that time, we will use this particular Hive query language. The data volume size is very large. The text analytical format, the input document format, it's a structured data oriented format. This Hive large data sets we are going to use for your data processing. Okay. So now we'll understand about HDFS or data model of your the data model of your Hive language. The data model, what it is doing, the data model which is location of your HDFS, where the Hive data are stored and retrieved under the HDFS layer. If you have the logical layer of HDFS, all the files are stored under the HDFS. Okay, the database, it's an internal table. It is completely structured table. All the data are stored and retrieved through the structured table. The Hive is having its own structure. It has its own table. It has a row and column. It's purely structure-oriented database operation you can able to perform through Hive. But the raw data are stored under the HDFS layer. Clear on this? The raw data are stored under the HDFS layer. The Hive will be processing through an SQL similar kind of query language, but the data operation when it is getting processed through the database where it's getting processed through the HDFS layer. It is a purely structure oriented language. It has containing the table has table operations. Based on the table operation, it is going to perform your all the data, large data operations. So here, the data model, the database and table. The Hive, if you are creating a database in a SQL server, if you are creating a database where the table or where the database is going to store, it is going to store under your hard disk. But if you are creating a database or table, where it's been going to store, it is going to store under the HDFS layer. Okay, it has its own table, it has its own database. Okay. If you want to create a table, it similar to our SQL server, we have our own primitive data types. It has its own structure of your similar kind of SQL server query language, but it's not always as it is as the SQL server query language. The syntax will be differ. The syntax or the command lines will be differ from the SQL server to Hadoop Hive. Okay, here you have to clearly understand there are a lot of syntaxes available, lot of query languages available. You have to learn through that. Based on the learning, you can able to easily understand. If you are aware of SQL server, it's very easy to understand of what is the keyword, what they specify. Hive is the not SQL. It's no SQL concept. What is meant by no SQL? Hive query language is a not SQL. Okay. So sometimes in the Hadoop environment, they will call it as a no SQL concept. So we need to understand that. So I can show you one slide for that. Maybe you can understand that very easily. What is meaning of no SQL? Sometimes when you are studying Hadoop, you might be seeing that somewhere people will say no SQL database, no SQL database. That means what? We have to understand that no SQL means the data types where you can able to store and retrieve is a structured way. Also, I can store and retrieve. No SQL will be a data types will be a document based data type. So it's kind of a row. It is collections of raw data in a document format. You can able to store and retrieve. It can able to store and retrieve the graph graph kind of store. The normal SQL server will be not like a kind of way. Data types will not be like that. Key value store. This particular way of methodology, you can able to data types can be stored in the key comma value pair of store. Wide column store. So this no SQL data types, there are 4 different ways you can able to specifically you can store the data types. That's called NoSQL. Okay, and then what is the benefit of the NoSQL? The benefit of the NoSQL, which is be more scalable, and then it is more superior perform than the normal SQL. It can able to process very large, very large of rapid changes in the structured data or semi-structured or unstructured data. So these are the way it is more benefit than the other model of SQL Server. So that's why it's called NoSQL. So HiveQL is not an SQL, but it is a similar kind of way of data analytical field tool. So in Hive, you cannot able to perform update or delete. Only you can able to read the data, and then you can able to do the operations. The location of your Hive, it is basically the store, the data where it been gets stored. There is a by default, you have to configure your HDFS layer based on the software configuration you have to do. The configurations are available under the our step-by-step guidelines of how to configure this HDFS layer. Okay, if you have any doubts, you can go to the particular meetup session under the files. You can go to the Hadoop guidelines. So under the Hadoop configuration, you can see how to configure this map reduce site engine. So everything will run under the SSH host. Okay, these three files, core site.xml, map site.xml, hdfs site.xml. These three files need to be get configured. So here the replication, whether it's one time or three time, you can specify where this map reduce sites engines are working. This configuration need to be specified based on the what is the parameter I specified over here. If he doesn't know how to do that, just go to that unzip the file, unzip the tar file, then go to check this three files, then open that file, then copy paste this what are the property I specified. Okay, so here only specifying your file server name, HDFS, where the HDFS need to work, how the map reduce engine need to be perform their task, and under the which server. So those kind of way it will be going to process. Okay, so this is the way you have to perform your perform your configuration of your Hadoop. So I'll unmute for a minute. So if you have any question, just ask me that. Anybody has any basic questions of Apache Hive?
Yeah, Mani, I'm having a question.
Yeah, please go ahead.
See, you told, right? So once we created the table in Hive, we cannot update it, right?
Yes.
So how to achieve that? Using other frameworks, or we have any other mechanism?
We have other mechanisms. We have other tools are available. If you want to do an update or other process, we have we can able to process through HBASE.
Oh,
okay. This Hive is one of the query language where you can able to do a predictive data analytical of large data. You can just store your data, and you're going to process the data. There you no need to do an update operation. First of all, when you are processing 1 terabyte of data, you're going to read the data, and then you're going to write the output file, but you're not going to write that existing data, because in the conventional method, if you're giving the input file format, like you are filling a customer form, there you are getting the input through the keyboard, but you are having a raw data here. Here you no need to update a raw data. If you want to change the data, you are going to rechange that new data set.
okay. So we can process the structure and semi-structured data in Hive, right?
Yes, we can able to process semi-structured and unstructured data, but Hive is purely designed purposefully for a structure oriented data. If you have a structured data, then you can choose for Hive. You don't need to write a Java program. You can simply you can call your data set. Based on the data set, you can just write your structured query language, SQL statement. Based on the statement, you can complete your business logic or business operations within a few minutes of time. You can write the program. Hive is designed purposefully for a structure oriented of data, but you can also process unstructured and semi-structured, but Hive is designed specifically for a structure oriented.
Okay, thank you.
Okay, so other things we have understood that Hive is the similar kind of SQL server. It's open source software, and then you can just download this Hive from your Apache org. You can go to the Apache org, then you can go to the software hive.apache org and the release. Okay, Apache Hive is one of the tool where you can able to go through this download. There you can download this software. Okay, Apache Hive has been started in the 2013. Based on the H catalog is there. The model storing is the horizontal way H catalog. Then there is a other concept. There are many concepts is there. These are some of the upgrade version. Current version is 2016 8th December. It is 2.1.1. Okay, so here you can just download this Hive software. You can download and then configure under the Ubuntu software, Ubuntu operating system. Now we'll see some of the commands of basic commands, but here I'm just telling about the how the basic commands are working. But there are advanced level of learning and the advanced level of syntax programming model is available. That will be come into a different training model. So this particular basic thing, you can see that what is a table. The table, what are the data types similar to our, for example, if you have a SQL server, there will be integer will be there. There will be a character will be there. There will be a string will be there. Then there is a varchar will be there. Similar way here, there is a different data type, data model, data schema are available. Here, the primitive data types are tiny int, integer, int, big int, boolean, double, string. These are some of the primitive data type, but there are many data types are available. But here specifically specified some small number of primitive data type. Tiny int, integer, big int. If you are seeing that big int and int and all, it is a very large number of size. The tiny int, whatever we are operating in the SQL server, the SQL server you have integer, that is a large means. Here the tiny int, the integer is very large. Big int is a very large number. Okay, the data size we have specified in the subsequent slide. You can go through that. And the boolean and double and string, these are the different type of primitive data types. If you want to create a table, how to create a table? So create table, table name, then you have the data types with the objects, the object oriented data types. Okay, the field name and then the data types. So the Hive QL, you cannot able to perform update or delete, but you can able to do the other query language. You can able to process your data. So what is the Hive benefit? The Hive benefit is it is a bridging the gap between the low level of Java programming and then Hadoop and then SQL. It is it's a programming model where you can able to connect the data set without Java language. You can write through an SQL query language. You can able to write the process your data packets. So it is also having the leverage of the Hadoop support partitioning for a scalability and performance. If you are having very large data, you can able to do a partitioning of your data. There are multiple table partitioning features are available through the Hive software. So the primitive data type, you can able to understand tiny int, small int, big int, boolean, float, double, and then string. So these are some of the basic data types we can able to understand. So there are other many things are available in the Hive. So I'll introduce certain basic stuff over to you. There are structure is there, there's map is there, there's array is there. These are some of the collections for collections of data type. One is a primitive data type, and then another one is the collection of data type. So other collection of data type is primitive, structure data type, map data type, array data type. So these are some of the different data types into the Hive. So how to create a database? Okay, so the database, to create a database, you have to use the command called create database, similar to our SQL server. Create database and database name. If you want to display the database, you have to use the command called show database. So there you can display the existing database names. So use database, where the use database will be useful for to what is the current data which need to be get used. Okay. Hey, once again, I'm getting one call. I need to take this call. I'll be back in a minute. Hello. Okay. Okay, I'm back. So we are discussing about the Hive and then how to create, what are the different type of data types, and then how to use the databases, how to create a database. Then we are moving towards how to use the database, how to show the table, all those things. Next things we are going to study about how to create a table. Okay, in a Hive language, how to create a table. For creating the Hive table, create table, movies, or here just a table name, and then the int. So here the int, tiny int or big int, whatever the data type you want to use. It's not similar to our SQL server, but the data types will be differ from the compared to the your SQL server. It has its own structure, it has its own syntax. All those things will come into picture over here. ID int, name string, year int, float, double, all these things will come into as a data type. Here to showcase the table, so for showing the table, we have to use the command called show table. And then if you want to showcase the what are the details in these tables, you got to use the command called describe. For if you compare to the SQL server, it has but here in Hive, it has its own different keywords are available. To describe movies, it's a table to describe what is the table is containing. If you want to delete the table, you can use the command called drop. Okay, so it is for removing the table from the system. So other thing is managed versus external table. So tables, whatever you're creating in the internal tables are controlled by the existing HDFS layer. Okay, the cycles of data which has been low conventional sharing with the other tools. We can also define the external tables where the point of the table does not ownership it, but also you can through the Hive we can able to connect the external tables also. The location of the table you have to specify where the location of the data is being reading from the data that should be managed versus the external table. There are two ways it is supporting: internal tables and then external tables. So if you want to alter the structure of your table, you have to use the command called alter table. The alter table, you have to use the command alter table, table name, and then the syntax of your table structure. Alter table, here the movie name, change the column, what column you want to change, what field name you want to change. You can specify the syntax of that particular structure. Based on that, you can alter your table structure. How to load a table? If you want to load a dumping of a certain data, raw data in a structured way, you can use any kind of data type. For example, you can create a dumping the data into CSV file or text file, or any kind of data type will be supported into the loading data. For that, you have to give the loading input path. Where is the file path is available under the, so here the movie.csv, which is a completely structure oriented database. That structure table, you are creating a similar kind of structure table in the Hive database, and then Hive table you are creating Then you're dumping the CSV file into your large data, similar to dumping of CSV file or DAT file or whatever the file format you have, that you can dump through this particular syntax. Load data in path of your, where is the location of your path. Then you are just dumping the data into your table. Then you are putting the from local, from HDFS. There is two types. You can also process your data from your local hard disk. Also, you can process your data from your HDFS hard disk, HDFS logical hard disk. If you are if you are not specifying anything, by default it will take from the HDFS layer. If you are specifying local, then it will go and take the file from your hard disk. It will not process under the HDFS layer. So the data units, what we studied about database and tables. There are other things that are available. It's called partitioning. So in Hive is a little big language, but if you study a lot, then you can able to understand many things. Partitioning is available, then buckets is available, or clusters is available. These are some of the data units that's most popularly used. But you might be aware of the table and database in normal SQL Server, but in the Hive language, you have to understand and study more into the partitioning, buckets, and clusters. So I'm just re-summarizing the primitive data types. There are integer, tiny int, small int, and kind of things. And Boolean data types is just a Boolean, and float data types is a float and double. And string data type, you can call it as a string over here. And there are some complex data types are available. That's called structure. And structure is a combination of multiple data types. And then the map, which is the grouping of multiple structure. And then array, which is the array type of data, which can able to multiple group of array type. And then how to write in a HiveQL, how to write a syntax of in a table. So there is a similar to our SQL server, there are data definition language, data manipulation language, similar kind of way. We have a data definition language of operations. So here you can able to do a create table, show table, describe table, alter table, drop table. So these are some of the operations you can able to perform through a DDL operation. So then you can go to the DML operations where you can able to data manipulation language. So here you can able to do the data manipulation language, so DML. So there you can able to load the data. So load the data. For loading data, you can able to load the data from the local path or the in path, where you can able to take from the if you're not specifying local, then it will take from the HDFS layer. So the data part where you can put the sample text file or CSV file or whatever the raw data file format you have, you can just put that file, that will be dump the data for your table for your data operation. That's the first level. Okay, after that you have to write so many other programs for your data operations, writing the business logic. What is the operation you want to perform? The select and filter, there are other keywords called select, where you can able to select how you are writing the select statement in your SQL server. Similarly, there is a select that from table name, where the conditions you can able to specify. And there is, if you want to insert a table, you can just put the insert and then overwrite. There is no update, but there is insert is available. So you have to understand insert is available, but there is no update. So insert overwrite directory, and then the location of the directory, and then star select star from the sample. Here you are just putting the location of the table directory, or overwriting or reading the table. From there you're selecting the values. Okay, where the putting the where condition, based on that you can able to, like a multi-query you are writing. Insert overwrite local directory, and then you are putting the output file format, where you can able to select star from the sample data table. It is taking the record and it is overwriting to the local file. So there are other things available. There are there are internal aggregation and group functions are available. One second, I'm getting lost. Hey, is it my audios are available? Hello.
Muted. Unmuted.
Hello. Sorry, my audio connection has been lost for a moment. Is it visible now? Is it my audios are clear?
Yes, Manikandan.
Okay. So we'll continue over there now. So we are understanding about discussing about the Hive language. HiveQL is similar to our SQL server. So there we understand about some of the basic commands. These basic commands are uh, similar to our SQL server query, but it has many query languages. I shared the book also. You can go through that. But if you want to understand the more concept, you have to read lot through that, and then there are many concepts available. For Hive itself, I have more than I have more than 600 to 800 slides where the concept is very large to understand about how to do a programming through Hive. So that you have to understand in the basic to become an Hadoop developer. Okay, so these are some of the basic commands I can able to go through that for an DML operations or the DDL operations where you can able to write the queries. You can understand the commands or select or filter. So insert or update, those things are available. So not update, but insert is available. Delete is available. So there are some of the aggregation and groups are available. Okay. So before that, I have some questions has been reached in the chat window. I'll just go through that. So Kader specified only tables are creating is possible in HiveQL. Database you can create, tables you can create. What else is required? You can just understand. Is it possible to create RDBMS object like procedure? Yes. There are so many other procedures or whatever the SQL server kind of things you can able to create. Those things also is possible to create over here. We can learn one by one on that. Okay, so here there are aggregate functions, predefined functions are available. These predefined function you can write a Java function also. That Java function also you can able to call over here. Okay, or you can write in the Python's function. From the Python function also you can call over here, but it won't predefine functions also available. You can just use that function also. It's an aggregate function or grouping functions like a count, sum, group by, max function, min function. Those are some of the initial basic function you can able to use for your aggregation and grouping. Select max of the field and then from table that will provide you the number of maximum number where it has been available. Select the count means where it can able to find the number of records or number of field is available or number of records is available over there, or counting or summing the particular field. Okay, from the sample database sample table, and group by is based on the field. From sample, insert override table where you can able to combine two different tables data into one single table also. That's simple aggregation of grouping. So then it is also possible in the HiveQL, you can able to do a multiple joins, right join, left join, all this kind of way. And here you can use the join command where you can for connecting to the multiple table structure. Okay, for creating a table you can use the table structure, and then for select table, when you're selecting the table you can use the joins, and then cluster joins are available, and then right join, left join, all these things are available. You can use this join command for. There are under the join there are so many syntaxes available, so many keywords are available. Those kind of combinations we can learn one by one. Okay. So there are multi-table insert, dynamic partition. This partition is very important in the HiveQL language. So normally in SQL server you might be used for normal select, insert. Those are the basic stuff. Okay, but in the HiveQL, why they have defined over there is the purely for multi-partitioning kind of concept. Multi-table, multi-insert, multi-dynamically it will work. So those are the very important concept in the HiveQL language. If you are working under the region specific, for example, if your large data set is available under the US region or India region or UK region, where the data sets are split into multiple region specific, when the data operations are performing, if you are having the partition of data, for example, if you are having the India database, okay, India database containing each 25 states or 26 states of data are available, there you can operation of data packet will be very large. For example, Aadhaar card system will have the multi size of terabytes of data for each state. If you want to process the data in SQL server, it will process the entire data packet, right? So but here you can able to put in a simple partitioning area specific to region, specific to state, specific to location, specific region, similar kind of any kind of way you can able to do in a partition. The partition is very important in the high language, so you can able to do in a data operation through partition. Also, it is containing the dynamic partition insert. So it is during the execution of things, there is a dynamic partition you can able to create, and then you can able to insert the data for the data operations. So and then few other user-defined functions you can able to create. How to write a user-defined functions. You can write the user-defined function through the Java code. There you can write the function UDF, that's user-defined function. That function also you can call through your query. Okay, similar to our default function, some kind of way. Here my lower case, converting to lowercase to uppercase to lowercase function. It's a user-defined function that I written in the Java. So that that has been used into the package.com.example.hive.udf. From that I imported the two import libraries. Then I'm created the class file. So there I'm creating the registration of the class. Then the com file under the com hive.udf.lower, that is a user-defined function that I'm creating a function over here in the registering the class. From that I'm using the select my lower. That function will be get called through that particular stuff, and then this query will be get executed through your user-defined function. Here if title, if I specify my underscore lower, the title, all the title will be displayed, converted into a lower case. Okay. So this is why it's a user-defined functions will work. So there are so many other built-in functions that are available in the Hive language. There is a mathematical languages. I'm here specified one or two only, but there are lot of built-in functions that are available. Round, floor, sealed, rand, expected experience, and then collections are available. Size, map underscore keys, map underscore value, array underscore containing. These are some of the built-in functions that are available. So you need to aware how to use these built-in functions, and each and every built-in function has its own syntax. So through practical exercise, you can able to understand all these things. It will come into other slides how to do programmatically how to do these kind of things. There are type conversion cast is available. How to convert the converting the cast type conversions, and then date functions are available. Date functions are available. Built-in functions, date difference, date year, to date. Those are so many built-in functions that are available. Those functions are need to be learned through for doing a high query programming language. The conditional functions are available. If case, those are available. Coalesce is available for checking the conditions. And then string is the length, reverse, upper, and trim. These are some of the string operations you can able to perform through the built-in functions. There are so many other aggregated functions that are available, min and max. This slide we already discussed. I'm moving to the next slide. So joins we discussed, multi-partition we discussed, user-defined function we discussed, mathematical function we discussed. There are more functions, programming stuffs are available. You have to understand how this functionality we have to create as a package program. So how to write a program into using these functions. Okay, that we have to learn through that. So now here only we are coming to the first level of step-by-step of how to write a MapReduce script into the Hive query language. Okay, so here using the Python also you can write the program MapReduce function. The same thing you can able to write, or using the Python script also you can write using this script. You can do a MapReduce functionality over here. So here I written the key comma value pair concept. What is the business logic I need to write? That has been written into the Python script. That Python script I'm using a command called using command. Select, transform the table values using the Python script as a key comma value pair. This key comma value pair, which is reading from the sample database, that sample database will be available in the HDFS layer. Okay, so this value will be get mapped into the key comma value pair. So there are other things is user-defined function, and then MapReduce schemes, how it has been different from the Java, and then how it is different from the MapReduce script which has been specified here. So here the language Java, the user-defined function you can create, but here in the MapReduce script you can write in the any language. Okay, it is a comparison of the Java and the UDF and then the MapReduce script. Okay, so here the Java will support the via UDAF framework, and then it is MapReduce script you can support. So UDF in the Java will be work into the faster, but in the MapReduce script it may be slower, but it will work for the very large data source. So there are other things we have to understand. There is a grep command, there is a ranking, there is so many other stuffs need to be understand one by one. But you can able to understand basic commands, so that will be to understand your basic commands, how to create a table, how to create a partitioning buckets, all those things you have to learn through that. What are the different data type? Based on that only you can able to understand about how to write a first few programs. Okay, so these are the basic commands. You can go through that, you can rerun this video, and then you can understand how these functions are defined, how to call these things. Based on that you can understand, but there are a lot and lot more. This another 200 300 slides are available to understand this entire end-to-end of concept to understand. Okay, so now I'm going to just comparing this same query language, which I'm comparing if I'm writing the Hive language, if I'm writing the HBASE or Hadoop, or if I'm writing the Pig language, how these query languages are running in the different engine or different compiler, how it is executing, which is faster. Okay, to understand that, we can able to do check it out. Hadoop environment, you can able to select query. If you're putting the select query, this is a comparison, performance comparison result. The same query, if I'm running under the Hadoop, it will providing the different timings of second with operation. When it's comparing to the Pig language, it will come giving a different result of timings. And when it's coming to the Hive, which is coming the lower time. So Hive is the performing very faster certain queries through join queries. Okay, so that is the performance result I want to explain to you the concept. So the same query, select star from where the field like some field. So query 1, query 2, join query, aggregation query. If you are running through the Hadoop environment, it will be a different timings. If you're running through the Hive, it will be in a different timing when you're running through the Pig. So which is the best tool if you compare? Each and every time will be differ. Based on that, you have to understand how to choose the tool wisely. Okay, so some of the nutshell you can recall the what are the things. It's Hive is just support query SQL based query languages. You can able to write the HDFS immutable, and then you can able to process through Hive. There are log processing, daily reports, user activity measurement, data text mining, machine language, training data, business intelligence operation. You can able to perform advertisement, spam detection. Many things can able to perform through the Hive language. Okay, these are some of the basic summary of your Hive query language. Those things. If you have any doubts, you just ask me. Based on that, we'll discuss further things. I'll unmute you. Just if you have any questions, we'll discuss. Anybody has any doubt?
Hey Mani, I am having small doubt.
Yeah.
So what is the difference between a table and the external table? So the external table is related to any external raw data, or it is something different?
It is external thing is something related to raw data, where you can able to connect the raw data, that you can import the data into your internal table. There also you can put the table. If you want to connect to you have some SQL server table you have available. The internal table, it's called about the HDFS layer. The data are stored in the HDFS. During that time also you can able to connect to the external data, where if it is available somewhere in the other location also you can able to connect. Those are called external tables.
Okay. For example, I'm having a table in Hive. So I'm getting a data every 1 hour. Okay, like for any social media data or any telecom data or any whatever harvesting data. Okay, so that is the external data, right? So can I insert the data in that internal table, like in Hive table?
Yes, you can able to insert the data when you are executing query. Yes, it is possible.
Okay.
You have to specify the command insert. When you are inserting during that time, you have to put the path. the location of the path, use the command called load table, load data. There you have to specify where is your location of your, here the CSV file is raw data. Here similar to raw data, the in path, you have to specify the path of the data table or path of the data structure where it has been available.
Okay.
Any other questions anybody is having?
Yeah, and one more question. So when we are dropping the table, right? So the table will be permanently deleted from that HBFS, or
Yes.
the
Here this Hive is the on top of your HDFS. The table structure, the table compiler, everything will be in another layer on top of your HDFS will be available. This is a separate table space, this separate database space. It is nowhere linked to with your HDFS, but the data packets are available into your HDFS layer. But the Hive has its own structure. It has its own table space. Okay, so there it been connected with your on top of your Hadoop layer. The compiler or the server, everything will be, data will be, metastore will be available in the Hive separately, but it will connect to your HDFS layer. If you are removing from the certain table, certain things you are removing, certain table, create database, what it will happen under the HDFS layer, it will create its own space. The database will be separate space. But if you have the raw data will be in the head and the HDFS in a separate place. If you are importing the data into as an input file, the HDFS file data, raw data will be import into your database or table. If you're deleting certain tables, it will remove from your table, but it will not remove from your HDFS layer. Raw data will not touch anything. But your data operation you are performing for your importing the data. After importing, you can do any operations. Any other questions anybody is having? Okay, we are reached 1 o'clock. So what we'll do, we'll continue the next sessions about the other topics like HBASE will continue over there in the next sessions. Based on that, you'll understand more onto this particular webinar sessions about understanding of the big data, Hadoop, Hive. There are 38 different tools are available. If you are running the 38 different week, also each week you can understand one topic. So you can able to gain the more knowledge onto the big data and data science field. So prior to that, I have some of the other questions. I will answer that. So I'll just leave this forum to you guys, and then you can share your thought process or share your knowledge or how the approach, how you're working out, so that other people will be get benefit. If you want, you can share your experience to the other people. Okay, some of the questions are in the chat window. I'll do one thing. I'll just summarize that questions in by email. All the questions I'll reply to that into our Meetup group email, so that you can able to understand that answers for that. Okay. So other thing is, thanks for attending the webinar sessions. You can keep learn many new things, and also if you have anybody want to willing to share your knowledge to the other forum members, you can just send an email to me, so that I'll create a slot for you, that half an hour or 1 hour slot. You can present your topic or present your the knowledge what you want to present to the other members about your project or about your approach to the other members, so that other members also will get benefited. This particular thing is the forum, community forum, but we have the operating the other chapters running under the for India locations, Bangalore, Hyderabad, and Mumbai, and many other locations. This particularly for the Chennai-based locations. We have creating dedicated repository website where all the materials will be maintained over there, and then the content like forum will be available in the 1st of April. We are launching the website, so that you can able to understand the job related things, you can join to the big data jobs WhatsApp group so that you can able to get the what are the job opportunities are available. And we have a dedicated job portal where you can able to apply the job through that, and then you can get the benefit of that. That's a community services only. And then other thing is we have a training model. We have 3 days training models schedules are available from April. You can join over there to understand more onto the, it is certification program. It's a 3-day certification programs where you can able to join together, and then you can learn many things on the, you can become a Hadoop developer through that training program. Okay, so keep sharing that your knowledge to the other people, keep learning the new stuff, and then keep post the valuable stuff to our WhatsApp group so that people will be in touch with you so that you also grow to your career life. All the best for you everyone to joining this who are joined this particular group, and then keep spread this group name WhatsApp group to the other members who are colleagues or friends who's interested in the big data and in Hadoop environment, so that this community will be grow in a very faster and rapid way, so that all the community people will be joined together as a one single hand. So we'll work towards to the next level of the IT industry revolutionary. Okay, thanks for joining. Share your feedback to the WhatsApp group, share your feedback under the video on the YouTube channel, share your feedback under the Meetup group. Okay, any question you just post me, we'll answer you. Thank you all.
Thank you.
Thanks, Mani.
Thank you. Thank you all.